So guys, now we'll be starting with our first orchestration framework called Langchain. So first of all, we'll be discussing the overview of the Langchain, then evaluation of the Langchain and the learning path. Because inside Langchain, there are so many components are available. So first of all, I will give you the entire overview, like why Langchain is important whenever we are developing any kinds of GenAI application. So without Langchain, what will happen and all. So each and everything I'll try to discuss. Then we'll be starting with the practical development. So our discussion about Langchain. Okay, Langchain. Okay. So see, first of all, let's try to understand what is Langchain and why it is required. Okay, so without Langchain, I mean, what will happen? So if I'm using any large language model, so what will happen? So can we build any application without Langchain, these kinds of framework? Is it possible to build the application? So first of all, let me, discuss the drawbacks. If I'm not having the Langchain, so what would be the issue there? Okay. So see, inside Generative AI, I think you already know. If I write here, inside Generative AI, okay. So what we use, guys, usually, I think you know we use different tools and technology, right? We use Langchain, we use vector database, then we use large language model, we also use llamaindex, then we also use, let's say, different kinds of web application framework, right? So these are the tools and technology we usually use if I want to implement any kinds of GenAI based product, yes or no, right? Now, whenever I'm talking about large language model, okay, whenever I'm talking about large language model, LLM, okay, LLM. So LLM is also having some limited power, okay. So why I'm talking about limited power, I'll just try to clarify. First of all, let's try to understand how many LLM we are having. Okay, so we are having many APIs, yes or no? Nowadays, we are having many LLM APIs. I'm not talking about, let's say, the, raw model. I'm talking about the API as of now. Just try to consider API part. So let's say we are having something called OpenAI. Okay, OpenAI API we are having. So OpenAI provides different kinds of large language model. Okay, all the GPT series actually will get here. Then we're also having something called Llama. Okay, Llama is also having their API nowadays. Okay, Llama 2 is there, Llama 3 is there, even Llama 3.1, I think they have also published. Okay, so these are the different model actually they are having. Then apart from that, we're also having something called Mistral. Okay, Mistral. Then I can write, let's say, so on. Okay, so on. That means so many models API we are already having. Okay, so these are what? These are nothing but our large language model, LLM. Okay, these are nothing but our large language model. Okay, now what is the problem? What is the problem? Let's try to understand the problem part. Now, if you see, this LLM is having limited. So here I can write, let's say, limited context. Okay, context window. Yes or no? If you see any kinds of large language model, if you go to their documentation, you will see that it is having one limited context window. What is context window? That means the input limit. So like how many tokens you can pass as an input to that large language model. So this is called actually limited context window. Okay. Now there is another problem you'll see, outdated knowledge. So outdated knowledge base. So if I'm talking about ChatGPT, I think mostly October 2023 actually they have taken the data over the internet and they train this particular ChatGPT model. That means this is the outdated knowledge base. Let's say if you ask anything, which is relevant to today's actually, let's say, information, let's say current information, right? So latest information, so it won't be able to give you the answer. But nowadays, if you see, ChatGPT has been updated a lot. If you also ask something in the real time, let's say I want some latest news, it will also give you the answer. But how they're giving the answer? They're using something called agents. Okay, they're real time fetching the information. I'll be also discussing the agents. What is agents exactly? With the help of agents, we can connect different kinds of APIs. Okay, so no need to worry. As of now, just try to think about whenever I'm talking about large language model, only large language model. I'm not talking about the ChatGPT. ChatGPT is an application, right? And it is using large language model. And what are the large language model it is using? GPT series large language model it is using. Okay, so now whenever I'm talking about large language model, definitely it is having outdated knowledge base, because till 2023 October they have taken the data and they train this particular model. Now if you ask anything which is let's say after October, or let's say after 2023, definitely it won't be able to give you the answer. Okay, so that's why we call it as a outdated knowledge base. The next problem you'll see, data privacy. Okay, data privacy. So you can't actually trust any kinds of large language model, because what happens actually, if you, let's say, give your private data, so there is a possibility your data may get leaked actually. So again, it's a data privacy actually problem you will be getting most of the time. Then if I'm talking about the cost, okay, the next one is the cost. Definitely cost is there. So if you are not sure about the, let's say, input, token size, if you're not let's say worried about the output token limit, okay, from your large language model, so definitely your cost will increase there. So you also need to take care about the cost whenever you are using any kinds of large language model. And when I'm talking about large language model, we also need a good configuration machine to execute that if you are using any raw large language model, okay, not any API. So API we can directly access with the help of API request, but whenever I'm talking about raw model, that means you are downloading the model and you are executing in your machine. So definitely you should have good machine. Okay, and if you also fine tune, if you also, let's say, train these kinds of model, it will include lots of cost. Okay, at that end of the day. Then the next problem you will see, no connection. Just let me write, no connection with third party. Okay, third party tools. So we see these kinds of large language model doesn't have any connection with third-party tools. So third-party tools means if I'm talking about any different website, let's say different website, or let's say different any kinds of data sources, it doesn't have any kinds of connection. Okay, now the last one you can write so on again. Okay, that means so many problem you can consider whenever I'm talking about large language model. That means it is having some limited power. Okay, if you see, it is completely having some limited power. Now see, with this limited power, definitely we can't create any kinds of generative AI based application, because whenever I'm talking about generative AI application, so let me just write out. So whenever I'm talking about Gen AI application, Gen AI application, okay, apps. So definitely you need lots of functionality. That means, let me just write down some of them. So let's say you need some data functionality. Let's say data in. That means you can input any kinds of data. Let's say you can input TXT data, you can input PDF data, okay, you can input, let's say, CSV data, you can also input, let's say, SQL data, okay, you can also input something called XLS data, you can also input HTML data, you can also input PNG data, and so on. Okay, so these kinds of functionality definitely your application should have. That means I can pass any kinds of data. It doesn't matter what kinds of format I'm using. It doesn't matter. I can pass any kinds of data. Yes or no, right? So if I'm talking about only large language model, you will see that large language model actually can't take these kinds of data directly. So for this, definitely we have to use some of the external tool. Yes or no? Okay. So that's what I'm just talking about. If I want to build any large language model, if I want to build any, let's say, generative AI based application, so I need these are the actually functionality in that application. Okay. So these are the tools and technology I definitely need. Then whenever I'm talking about, let's say, some of the, let's say, actions, okay, actions of your application. So it can perform, let's say, RAG. It can perform, let's say, agents. Okay, it can also give the APIs. It can also format your data. It can manipulate something. Okay. Then it can, let's say, transform something. It can store something. It will have some memory. Okay, so that it can remember your conversation. Okay, then it can also connect with third party. Okay, third party tools. Got it, and so on. Okay, then it will also have something called data out. That means it will also give you some kinds of output. I can call it as data out. Okay, and data out wise, what it can do, guys, it can return anything. Okay, any kinds of, let's say, output it can give. So here I can write anything, whether it's a image, whether it's a, let's say, text, whether it's a video, anything it can actually return as an output. Got it? So that's how actually we build any kinds of Gen AI based application. Okay, Gen AI based application. Got it? But if I'm only using, let's say, LLM, large language model, and see, large language model, it's not like that actually. It will come as an individual model. Okay, so it will be published by some of the organizations, some of the company. So let's say I'm talking about OpenAI. Okay, so let's say I'm talking about OpenAI here. So OpenAI is a company, OpenAI is an organization. So if you see, OpenAI is also having their own platform. Yes or no? I think you saw. If I search for OpenAI, okay, openai.com. So this is the OpenAI platform. I think you already aware about this particular platform, guys, how to use the OpenAI platform. So OpenAI also give you one Python package. I think you remember, guys, Python package OpenAI also give you. So with the help of that Python package, what you can do, at least you can interact with the model. So it won't be having all kinds of functionality, like to build your generative AI based application, but most of the functionality it will also provide you. Okay. Now let's say you have learned this OpenAI framework. It's fine. Let's say you have learned this framework. It's completely fine. Now there is another requirement. You have to use Llama model. Okay. Then what you have to do, you can't use OpenAI framework in the Llama model. Okay. You can't ever use that OpenAI framework in the Llama model to load the Llama model. For this, what you have to do, you have to again learn the Llama framework. So Llama is also having their own framework, okay, from the Meta site. So you also need to learn that particular framework. Okay. Now let's say again you have learned the Llama framework. It's completely fine. Now there is another requirement. You have to use Mistral model. Again, you can't use OpenAI and Llama framework to load the Mistral model. Then what you again need to do? Again, need to learn the Mistral framework. Okay. That means if I'm talking about different kinds of large language model, so you also need to actually learn different kinds of framework. And again, it's not actually efficient way, because as a developer, how many framework you will be learning, and it's not possible to remember all the framework. So it would be very difficult for us. So can I use only one kinds of, let's say, framework, one kinds of library, and with help of one kinds of library, I can, let's say, load all kinds of model. I can perform all the operation, whatever operation I've written here. Is it possible? Yes, it is possible. So that is why actually your Langchain comes into picture. Okay, Langchain comes into picture. So Langchain, what they did actually, they created one. But I can say they created one common framework actually. So this particular framework can, let's say, use all kinds of large language model. Not only large language model, all kinds of generative AI service, they can use this particular Langchain framework. That means this is a universal framework. Okay, that means it can support everything. Now you can ask me why we have to choose Langchain. There is another framework in the market called llamaindex. I think you know. Okay, llamaindex. Okay, llamaindex is the alternative of Langchain. So both are good framework. I'm not telling llamaindex is bad, Langchain is good. It's not like that. Both is having actually their different kinds of ability. Okay, I'll be also discussing more about llamaindex later on. As of now, our main intention is to focus on the Langchain, because here, if you see the series actually I'm taking, it is related to the Langchain. Okay, now let's try to understand why Langchain we have to choose. Just try to remove it. So here, let me write why we choose Langchain. Okay, why we choose Langchain. Okay, so what is Langchain? First of all, I already told you Langchain is a orchestration framework. Okay, orchestration framework. Okay, that means it's a complete generative AI framework. So all kinds of orchestration you can perform with the help of Langchain. And inside Langchain, you will see there are different update came nowadays. Okay, so many things they have integrated. Let's say they have integrated LLM ops. Okay, LLM ops technology. That means you will see they are also having ecosystem like Langsmith. Okay, Langsmith very popular nowadays. Then Langsarp. Okay, very popular nowadays. Then we're also having something called LangGraph. So with the help of LangGraph, what we can perform? So this is for actually monitoring. This is for actually deployment. Okay, deployment. And this is for actually agents or multi-agents. Okay, multi-agents. So these are nothing but our LLM ops tool and technology. LLM ops tools and technology. Okay, now if you see, these are the actually ecosystem. So it is built on top of Langchain exactly. if you see all the, let's say, framework, let's say all the LLM ops tool, it is built on top of the Langchain. That means they're using Langchain language only. Okay, they're using Langchain language only to implement these kinds of framework. Now, whenever you are working in the generative AI market, let's say there is a requirement, you have to implement one generative AI application, and there you have to implement one agents. Okay, that means it will have the multi-agents ability. So definitely, you know that if I want to create the multi-agents, okay, multi-agents in my let's say application, what I have to use? I have to use something called LangGraph. Okay, I have to use something called LangGraph. Now, LangGraph you can't use with the help of llamaindex. Okay, llamaindex actually doesn't support this LangGraph. That means you can't use it. Then what you have to do? You have to use something called Langchain. So definitely you have to learn the Langchain at the end of the day. Yes. Now let's say you want to create a POC deployment. You want to create an API of your application, and you want to use LangServe for this. Then what you have to do, guys? Again, you have to learn the Langchain, because Langchain supports this particular LangServe, right? Then let's say you want to monitor your application. Okay. That time, let's see, if you want to use LangSmith, so what you have to use? You have to use the Langchain again. That means if you see here, wherever you go, okay, wherever you go in today's market, at the end of the day, you have to use Langchain only, because Langchain is having all kinds of ability. Okay, all kinds of ability it is having. Okay, there are some alternative as well. Okay, you will also see in the market there are some alternative as well. Let's say LangGraph alternative, you can use something called this one. The alternative of LangGraph, you can use something called ChromaDB. Okay, ChromaDB. So let me write it. ChromaDB. So ChromaDB is a framework with the help of, you can also create agents and multi-agents. Okay, but again, I'm talking about the complete Langchain ecosystem. Let's say if I'm having something in the Langchain, so definitely you won't be using any third-party, let's say, tools and technology. Okay, because if you're familiar with Langchain, so most of the, let's say, ecosystem you can automatically work with, because the language is same at the end of the day. But if you ask me which one is the better, okay, see, understanding wise, I will suggest you can learn the ChromaDB, because ChromaDB, you will see the syntax wise, functionality wise, it is like very easy to understand. Let's say with compared to your LangGraph. So I will show you some of the example in future maybe. So there you can see with the help of both framework, we'll be creating the agents. But there we will automatically try to understand. Okay, so what is the difference between ChromaDB and LangGraph? See, ChromaDB at the end, they're also using Langchain. Okay, Langchain in the backend. Okay, Langchain in the backend, and they implemented one high-level framework. Okay, for the agents and multi-agents. I think you know about, let's say, this one, TensorFlow, guys. I mean, what was the TensorFlow? The previous TensorFlow, I think TensorFlow was separated library, yes or no? But if you see the Keras implementation, internally they're using TensorFlow API only. That means TensorFlow language they're using, and they have created one high-level wrapper on top of it. Yes. This is called actually Keras. Then what TensorFlow thought, because Keras got more popularity in the market because of that easy to use, because all the developers started using the Keras. And that time TensorFlow thought actually, can we collaborate with the Keras so that we can bring the Keras in our, let's say, library. That means we can import like that from TensorFlow, import Keras. But previously we used to import Keras like that, import Keras directly, right? So that's why they collaborated, and they actually, they took this particular, let's say, Keras framework in the TensorFlow API. Okay, so the similar wise, so ChromaDB is also a library, different library, but at the end of the day, internally they are using Langchain API only. Okay, Langchain language only, but they created one high-level wrapper on top of it. Okay, so that whenever you are getting any kinds of agents and multi-agents, you can create in a good way. So you don't need to write too much of code. You don't need to do so many configuration. So they have already created some pre-built functionality. With the help of that, you can directly use them, right? But see, whenever I'm talking about ChromaDB, so here you don't have like lots of customization option. That means as a developer, you won't be able to customize your, let's say, agents, because it's a high-level wrapper at the end. It will give you some functionality. But let's say you need a customization. You have to customize everything. That time what you can do, you can use LangGraph, because LangGraph will provide this kinds of customization ability. So if I'm talking about Windows and Linux, so which is having more customization, guys? Tell me. Definitely inside Linux, because Linux is kinds of open source, and it has actually given me everything. Okay, so that I can customize everything here. But whenever I'm talking about Windows, so we are having some certain, let's say, a modification we can perform. Okay, if I'm talking about Windows, Mac OS, so there are some certain operation we can perform. Okay, customization we can perform. But if I'm talking about Linux, everything you can customize. You can even write your own code there. Okay, let's say you don't need this kernel. You can also write your own kernel, and you can use it in the Linux operating system. Okay, so now I think this part is clear, guys. Okay, what is this Crew AI and LangGraph. So now I think you got some understanding why we have to choose the Langchain, because nowadays whatever, let's say, evaluation you can see in the field of generative AI. Okay, so all the, let's say, technology is coming in the Langchain. Okay, very frequently, because they are bringing like so many, let's say, tools and technology for you, so that you can use them to create your generative powered application. Okay, now I think it is clear. That's why we have to choose the Langchain, because it is having all kinds of ability. Now if I'm talking about Langchain evaluation, okay, Langchain also evolved, I think you know, as per your large language model evaluation. So Langchain also evolved. So let's me just discuss about Langchain. Okay, Langchain evaluation. Okay, Langchain evaluation. So see, previously, I think those who have used Langchain, I think you know, Langchain only used to use something called, I think, LLM model. I think inside LLM model, we are having two kinds of model, I think you know. One is completion model. Okay, completion model. And this like chat model. That means if you see from LLM model, that means generation model, completion model. Okay, LLM model. They also, integrated chat model ability in their framework. Okay. Then the second evaluation you can see from legacy. Okay, from legacy Langchain to LCEL. That means Langchain expression language. Okay. Then they also evolved from LC, okay, Langchain to Langchain ecosystem. They also created ecosystem. Okay, ecosystem means they have created different ecosystem, like I already told you na. So you can see they created Langsmith, Langsarp, LangGraph. Okay, so these are the ecosystem. Okay, they created. Then one very interesting thing, even I usually explore a lot, from terrible documentation to, here I will just write ... Okay, why ... Now you can tell me, guys, if you're using Langchain documentation, maybe you will be able to answer me. Okay, so previously if you see the Langchain documentation, it was terrible, right? It was very nasty and terrible. Even it was out of brain for me also. When I started learning Langchain, I was to refer the documentation. It was very hard to understand. Okay, now if you see in today's Langchain also, if you see that documentation, I can't say it's a they created like easy documentation, but again it's hard to understand most of the syntax, because you will see that and they will be writing too much code. Okay, too much code, and if you go to the documentation, definitely will get confused. Okay, like what is happening here? So again, I can say it's not a exact actually easy documentation they have created. That's why I've given ... That means still it is terrible for the developer. Yes or no, guys? If you see the like llamaindex documentation, it is easy to understand compared to if I'm talking about this Langchain. Personally, I don't prefer the documentation the way actually they have written the documentation, but compared to actually Langchain, llamaindex documentation is a little bit good. Okay, what I feel like. Okay, yes. Now yeah, so these are the actually evaluation actually they did in the field of generative AI. That means first of all, we had actually completion model only inside large language model. Then we switched to the chat model. Okay, so let me show you some of the example of completion model and chat model. So for this, what I can do, maybe I can open the playground, OpenAI playground. See, this is the OpenAI playground. So if you see, this is the playground of the OpenAI. Now below you can see this is the completion. Okay, completion actually playground. So here they're using something called completion model. And what is completion model? You can see these are the completion model. So GPT 3.5 Turbo Instruct, GPT 3.5 Turbo Instruct 0914, then Babbage 001 and Dependency 002. Sorry, Babbage 002 and Dependency 002. Okay, so these are the actually completion model. And now what is completion model? See, completion model, here you can't pass any kinds of system prompt. That means you only need to give the user input. Okay, user input. That means you can perform the conversation. Okay, here you can perform the conversation. So here you can, let's say, generate something. Let's say here I can write a poem Okay, poem for me. Okay, so if I see send the prompt here, okay, so it is telling, yeah, so not yeah, so now it is, see, it is generating the poem for me, and you'll see that it's a generation model. So here you can't perform any kinds of, let's say, conversation. Okay, conversation, actually it's not possible. It's a complete actually generation model you are using, completion model you are using. Okay, now if I switch to the chat model, see, nowadays all the model, this is a chat model, chat completion model, whatever model you can see nowadays. Let's say new model GPT-4o. See, here is the list of the model: 4B turbo, 4, 3.5 turbo. Okay, so these are actually complete chat completion model. Now if I'm talking about llama, if I'm talking about Mistral, Falcon, whatever model you can see, so all kinds of model are chat completion models nowadays. That means you can also perform the conversation, and this model can take two kinds of input. One is the system instruction. Okay, system instruction. So here you can specify what kinds of, let's say, task you want to perform with the help of your model. So here I can give any kinds of, let's say, system prompt. Let's say you are an expert. Okay, expert to write poem. Okay, poem. Okay, so you can give any kinds of system prompt here. So let's say I've given this one. Now you can give the user input. So I can write, I am very happy today. Please tell me a poem. Okay, poem. Now see, if I give it to the model, see, you will get actually a very good response. And you see the response actually we are getting the level with assistant, and whatever input you have given, you are a user. That means you are doing the conversation. Okay, conversation here, and this is called actually chat completion model. Okay, chat completion model. Now let's say you didn't like this particular poem. Now what you can do, I need some let's say excitement in this. Now see, here I haven't specified. Okay, I haven't specified this poem I'm talking about. Okay, I just written, I need something excitement in this. Okay, and it will automatically understand I'm talking about this particular poem, the poem actually it has given me. So this is called actually conversation. The way we do the conversation with the human, right? Let's say between two person, between three person, the same thing actually they have mimic inside the large language model. That means you can perform the conversation with that. Okay, and you can specify any kinds of system instruction here. Okay, so this is called actually chat completion model. Okay, now I think it is clear what is chat completion model, what is completion model only. Okay, now see, previously whatever large language model we used to use, this was actually completion model, and Langchain only was support Langchain only actually created the functionality related to the LLM model, that means the completion model. But nowadays if you see, they also created the functionality related to the chat model. That means it can also load all kinds of chat model. Okay, all kinds of large language model, not only completion model, it can also load any kinds of chat model. Okay, then from legacy to LCEL, that means if you see the previous syntax of the Langchain, it was different. Whenever we used to create the chains, we used to use some of the function from the Langchain, but nowadays they created something called Langchain expression language. Okay, that means instead of using the function, what we can do, we can create a pipe. Okay, I think you can see nowadays people are using pipe. Okay, so people are using pipe. So with the pipe actually we can create the chains. So we don't need to use any kinds of, let's say, function for any kinds of chains. Okay, I'll also tell you whenever we'll be doing the practical, that time I'll tell you what is the difference between the legacy Langchain and what is the difference between the this one Langchain expression language. Okay, everything I'll try to clarify. Then they created the ecosystem. That means they brought actually different kinds of ecosystem like Langscape, Langsmith. Then they also brought something called I think Langscape. Okay, so these are the ecosystem, and from terrible documentation to, I think I can say again, it's a terrible documentation only for developer like us. Yes or no, guys? Okay, so this is the complete evolution of the Langchain. Now see, one thing you just need to remember. So it is very important, guys. Even I always say this to my student. See, this generative AI space is the fastest evolving space in software industry. Okay, software industry. Okay, so no matter how hard I work, the content will never be 100% okay up to date. Okay, it's not possible. How much hard I work, the content won't be never 100% up to date, because it's like very fastest evolving space in the software. Okay, but here note, okay, note it, but you will be ready. Okay, you will be ready for anything. Let's say if I'm teaching you something, definitely you will be ready for anything. Okay, and I always tell here, I do not give you fish. Okay, here I will teach you. I teach you how to fish. Always try to remember this line, guys, because let me show you one example. Let's say if I go to the Langchain let's say package. So if I just search Langchain PyPy, let's open this Langchain PyPy. Now if you go to the release history, now see the release date actually. Okay, just see the release history. So what is the last update, guys, of the Langchain? It's October 9. Okay, October 9. And tell me, when was the October 9? I think it was yesterday only. Okay, yesterday they updated the version of the Langchain. Now you'll see that the previous update, it was October 4, September 26, September 14, September 12, September 6, September 4. Okay, you will see that very frequent update. Now tell me, if I'm teaching you something, okay, and let's say after 1 month, definitely there would be so many updates in the Langchain. Yes or no? There would be so many updates in the Langchain, in the Generative AI. Now tell me, is it possible for me to again, create the course? Tell me. No, right? But if you see the actually, concept wise, they're using the same concept, but they're changing some of the syntax. That's it. Okay. Previously, whatever legacy Langchain we used to use, it's completely fine. All kinds of functionality we can use today, but some of the syntax has been changed. Okay, some syntax has been changed. That means previously we used to use function. Okay, function to create a change, but nowadays what we do, we create a pipe. We use pipe symbol, okay, to create that particular change right now, and this is called actually LCEL. That means Langchain Expression Language. Okay, small modification they are doing, but they're releasing so many version, and people are getting confused. Sir, you created this course, you are using older version of the Langchain, so it's not fair. But you just need to try to understand, okay, why we are creating with the older version of the Langchain. Because if you see older version of the Langchain, you will see there some of the version is stable version. That means they have created this version in such a way all kinds of functionalities are available. Okay, because developer are using, it's not possible for the developer to change their version, different version always. But let's say you have created one software. Let's say you created this ChatGPT. Let's say today you have created, after 1 month, again another version of the Langchain will come. So will you again change that code in your code base? Tell me. Again you will change the code in your code base? No, right? So what we'll do, whenever you are creating any kinds of software, first of all you will try to select one specific, let's say stable version. Okay, stable version of the framework, and with the help of that you will be developing the entire, let's say, software. Yes or no? Okay, so that's why whenever I'm teaching you something, I'll be using one specific, let's say, framework, a specific framework. I'll be using some specific version. Okay, because it's not possible, let's say, when I created the content that time, let's say I was using this version, but after creating the content, when I started teaching, so they have released so many versions. Again, it's not possible for me to again update my content, right? Yes or no? But if you see, they are not doing, so many major changes here. Small changes they are doing. Sometimes they're bringing some new, let's say, syntax. Sometimes they're bringing some new functionality. That's it. Apart from that, you will see they're using the same legacy Langchain only. Only some of the syntax has been changed. I will do the practical also. That time you will also get it. Okay. Some of the functionality they have changed, but apart from that, whatever legacy Langchain you used to use, the same functionality will remain here also. Okay. That's why I always tell this line. Okay. So here, how hard I work, okay, in the field of generative AI, but the content will not be ever 100% up to date because of that. Okay. And here I will see, I'll teach you how to fish, exactly how to learn. Okay, how to learn. Let's say if anything is updating by the framework. Okay, if anything is updating by the framework, or let's say if any new changes is coming. So as a learner, as a developer, definitely you will have the ability to understand, okay, what is coming in that. Okay, so don't always try to rely on your mentor. If you're relying on your mentor, so you ever, it won't be possible for you to be a good developer at the end of the day. You can trust me, guys. Okay, so always you have to learn, okay, learn the concept, like how this concept is being utilized here. Apart from that, if anything is coming in the market, if any new update is coming, you have to explore that. So always you have to do explore, guys. 3 things you have to do: explore, okay, explore, research, and practice. So these 3 things if you have, definitely you will be a good developer. You can solve any kinds of problem statement, trust me, guys. So that's why here I do not give you the fish. Here I'll teach you how to fish. That is my main objective. Yeah, so that's why see, whenever we're learning the latest Langchain, it's not like that everything has been changed in that let's say framework. Some of the, let's say, functionality they have changed, some of the, let's say, new syntax they have introduced, but here we'll use the legacy. Okay, still we'll be using the legacy. Still will be using the legacy Langchain, because still it is using Langchain team is also telling you have to use legacy let's say Langchain still if you want to create any kinds of GenAI application, because we are not able to actually, let's say, change all the framework. That means all the syntax, it is not possible to change. Some of the functionality we brought, but still you have to work with the legacy Langchain. Okay, so whenever I'm talking about, let's say, memory, okay, memory nowadays, okay, memory nowadays, let's say when you want to add any memory to the application, you will see that people are still using legacy Langchain actually syntax. That means they're using some function, okay, some function, let's say buffer memory function. They're using some, let's say, window buffer memory function. Still they're using that one, because in the second generation Langchain, these kinds of memory they haven't introduced. Okay, they haven't introduced these kinds of memory kinds of functionality. I think recently they published one version. I think they're telling like we integrated actually permanent memory, okay, with this framework. But again, you'll see that they're using the same kinds of things only, okay, at the end. Now let me discuss about the learning path. Learning path, like how we'll be learning this Langchain. Yeah, so first of all, here I already given you the introduction and the overview why Langchain is required and why we'll be using Langchain. Okay, so then next session we'll be discussing about how to talk with LLM with the help of Langchain. That means we'll be using different kinds of large language model. We'll be using OpenAI large language model. Okay, we'll be also using open source large language model. Okay, so all the things we'll be exploring one by one. Okay, then we'll be discussing about how to work with the data, how to work with data. Let's say if you're having any custom data, custom documents, then how you can load these other documents, how we can connect your large language model. That means we'll be discussing about basics of RAG. Okay, basic RAG we'll be discussing here. Okay, then fourth we'll be discussing about something called chains. Okay, chains is the main thing inside Langchain, because at the end you will be creating the chains. It's a step of execution. Nowadays inside Langchain expression language, they introduce something called runnable. Okay, runnable. Okay, runnable. They call it as runnable. Previously we used to call chains, now you'll be calling as a runnable. Okay, then I'll be also discussing something called memory. Memory, that means if you want to add any memory, that means if I go to the chat GPT, if I ask if I'm asking something, it can remember my conversation. Okay, so this kinds of, let's say, memory, how to add, I'll be also teaching you this thing. Then we'll be also discussing about the ecosystem. Okay, ecosystem, that means here we'll be exporting Lang, Smith, Lang, Serve, and Lang graph. Line graph. So this kinds of ecosystem we'll also try to understand. Then once everything we have completed, okay, we'll be also doing some development. That means we'll be implementing some level 1 application. Level 1 application. Okay. Apart from that, in the advance, you will see that we are also having something called level 2 application. We are also having something called level 3 application. So this level 3 application is the professional. Okay, professional LLM application. Okay, LLM apps. That means here we'll be using something called full stack development. Okay, full stack development. So these are the actually application level. Okay, and as a generative AI developer, let's say if you want to create a professional application, that time you need to know how to create the level 3 application. Okay, with the full stack development. Okay, so yeah, I think you got the entire learning path. Okay, how we can learn this complete Langchain. And apart from that, you don't have anything inside Langchain. Okay, so guys, now let's see how we can connect with different kinds of large language model with the help of Langchain. So here I will show you how we can connect with OpenAI GPT model. Even I will also show you how we can connect with any kinds of open source model like Llama 3, Mistral, and so on. So as I already told you, OpenAI GPT model is best model so far. So in this program, we'll be using this model. Okay, whatever project actually we'll be implementing, we'll try to use this model. But if you also want, you can also connect with any kinds of open source model. Okay, that alternative I will also show you how we can connect with open source model. So let's start with our practical demo. How to talk with LLM. Okay, with Langchain. Okay. So see, whenever I'm talking about how to talk with LLM with Langchain, that means we'll be interacting with the large language model. Okay. So here, the first thing we'll be exploring. We'll try to see how we can connect with the most used LLM. Okay, LLM, which is nothing but our OpenAI. All right. Then we'll be also learning connect with alternative, okay, alternative large language model. That means we'll be also exploring some open source, okay, open source API as well. Fine. Then we'll be also learning talk to LLM in different language, different language, because most of the people actually they are using English language. Even if you see, these are the large language model is trained with English language, but let's say you want to do with any other language, let's say Spanish or any other language. So is it possible or not? Definitely it is possible, but I'll tell you, okay, I'll tell you some drawbacks you have to remember whenever you are using different language. Then I'll be discussing about introduction to prompt template. Along with that, we'll be also learning something called chains, okay, chains and output parser. Now you can ask me why here I have written the most used LLM, okay, the OpenAI, because see, whatever model you can see in the market, let's say I'm talking about Meta, Llama, or let's say Mistral, okay, Mistral, Falcon, okay. So whatever model you are talking about, this model is good at the end of the day. If you want to build some POC, okay, this is completely good, you can do it. But whenever it comes to actually a real-time project implementation, that means you want to create any robust application, very robust application, okay, that time it is recommended to use OpenAI. Okay, because OpenAI is the better model so far. Okay, whatever model we are having, like the Meta, Mistral, Falcon. Okay, apart from that, this OpenAI is the very powerful model, and it will give you more accurate response. Okay, and if I'm talking about the cost of the OpenAI, it is also less. It's not actually very much. If you're taking care, let's say all the prompt template, let's say all the, let's say small things, definitely you can also reduce the cost. Even I'll also tell you how we can reduce the cost, how we can monitor our application. Okay, everything we'll try to discuss, no need to worry. So see, it is always actually suggested, if you want to create a robust application, if you want to create a real world product which you will be using in the production, that time go with OpenAI model, because OpenAI model is far better than your open source model. That means let's say any other alternative model wise, it's fine, you can use it, there is no issue, but you can use them as a POC. Let's say you want to create a project and you want to just, let's say, create a POC kinds of, let's say, application, that time you can do it. But whenever it will go to the production level, that time I'll suggest try to go with the OpenAI model, because this is far better than your Meta Llama 2, okay, or let's say Mistral, Falcon, whatever, let's say open source model you are having, it is better than that. Okay, so that's why actually OpenAI is a chargeable, because this model is very good, and if you want to use them in the production, definitely you have to pay some money. Okay, and these are the model are open source because they have make them open source so that you can at least explore the generative AI. You can create different kinds of application as a POC kinds of, okay, let's say application, and you can at least test that particular application. Okay, this is the main idea. Okay, that's why here I have written the connect with the most used LLM. Okay, that means OpenAI model is the most used LLM. Okay, which is nothing but GPT series. Then you are also having some alternative option. Let's say you don't want to, let's say, create the OpenAI API key, you don't need to spend some money. At that time, you can also use the alternative approach. Okay, I'll also tell you how we can connect with the alternative model as well. Okay, then we'll be discussing about talk to LLM with a different language. That means if I want to, let's say, communicate with my large language model in a different language, let's say Hindi, Bengali, whatever, I can also do it. There is no issue. But you will see that English accuracy will be getting more. Whenever I'm talking about English language, you will be getting, a very good accuracy there, because these are the model has been trained with English data. Most of the data will see that all over the internet, it's English data. Yes or no? Okay. So that's why sometimes some hallucination you might get if you're using any other, let's say, language. So that part you have to take care. Got it? Going forward, you'll be also learning how we can fine tune these are the model on top of our custom data. Okay. How we can get a RAG application on top of our custom data. So that time also you can create this kinds of, let's say, project. There is no issue with that. But most of the time, if you want to use a different language, so make sure this language is available. The model actually you are using. Otherwise, you have to fine tune that particular model. Okay. So the first thing will be we have to do the environment setup, because everything will be set up in our local machine. Because most of the, let's say, most of the tutorial you will get, people are using Google Collaboratory. Okay, they're using Google Collab to set up everything. And we know that inside Google Collab, actually, we won't be facing any kinds of error, because inside Google Collab, we are having already pre-installed all the package. Yes or no, right? So when it comes to the local setup, people will get the difficulty for sure. So that's why I will more focus on the local setup everything, because at the end of the day, whenever you will be developing something, you have to set up everything in your local machine. Okay, no need to use the Google Collab that time. So that's why we have to learn how we can set up everything in our local machine. That is the idea. Fine. So guys, what I will do, I will open up my local folder. You can see here I have created a folder called Langchain latest. Inside that, I'm going to open up my terminal. Okay. So you can also open up your git bash, anaconda prompt, whatever terminal you are using. Just make sure, try to open it, and make sure you are having anaconda. Okay, anaconda install, everyone. So I'm expecting you are already having the anaconda in your system. Okay. Now the first thing, what I will do, guys, I'll just try to open up my Visual Code Studio here. So this is my Visual Code Studio. Let me zoom. So here I'm going to create a file called readme, and code would be also available in the description section. Otherwise, what I can do, I can create one GitHub repository. There I will be uploading. You can also get the code from there. Okay. So readme.md. So inside that, I'm going to mention all the command you have to execute to create the environment, to set up your all the requirements. Okay, all the command I'll try to mention here. So the first thing, let me give a comment how to run. So the first thing, you just need to create an environment. So create I can write conda create. Okay, conda create hyphen n. Now you just need to give the environment name. Let's say I'll give LLM app. Okay, LLM app. Now you have to specify the Python version. So Python is equal to let's say I'll take 3.11. Make sure guys you are using 3.11. Why 3.11? Because 3.11 is the stable version so far, okay, inside Python. So that's why we are using, because it supports all kinds of library. So you won't be getting any kinds of installation issue. So see, it's always recommended. Let's say whenever any package or any, let's say, version is coming in the market, if you see the Langchain is like very frequent update, yes or no? Okay, so every day they are bringing new features. So they are doing some small modification, but apart from that, everything is remaining same. So similar wise, Python is having also so many version. So it is having 3.11, 3.12, I think it is also having. So we are not going to use the latest version. Instead of that, we'll be using at least some previous older version. Okay, why previous older version? Because people have already used these at the, let's say, version in their project implementation, and it was working fine. Okay, it was working fine. There is no error. So that's why people has decided, okay, this is the stable version of the Python so far, so you can use them. Got it? So if you search over the internet, you will see different kinds of blog. People have already written, okay, what is the stable version of Python and why you should use it. Okay, everything they have already written. So that's why instead of installing the latest version, always try to install at least some fewer older version. Okay, that will help you a lot. You won't be getting any kinds of error. So that's why here I'll be using Python 3.11. So then I'll give another line hyphen y. That means I want to give the permission to create the environment. All right. Now the second thing, after creating the environment, you have to also activate the environment. For this, you have to execute this command called conda activate. Okay, LLM app. So this is the command, guys. Then to install the requirements, you just need to write pip install. Okay, hyphen r the requirement.txt. So these three commands you have to execute one by one. So for me, I already created the environment. So let me show you. So let me just activate the environment. But for you, if you don't have the environment, guys, just try to execute this line. Okay, once you executed the line, it will create the environment. After that, you have to activate that. See, this is the command I'm executing, conda activate LLM app. Now see, if I press enter, you'll see that LLM app has been activated. That means I already have the environment in my system. But for you, you just need to create it, guys. So see the command and try to create the environment. After that, here I'm going to create a file called requirement.txt. So requirements.txt. So inside requirements, you have to mention all the requirements you need. So let me mention the Langchain package. So here I can write Langchain is equal to. See, if you are not giving any kinds of version, that means it will install the latest version. So if I go to the Langchain documentation, or let's say Langchain PyPy. So Langchain PyPy, open it up. If I go to the release history, you'll see that this is the latest version. Okay, it will install the latest version. But what I told you, so don't try to use the latest version always. If you want to create a robust application, at least just take the fewer version of the old version of that particular package. Okay, so here I'm going to use one version of the Langchain, which is nothing but 0.2, because you can see Langchain is currently 0.2 series. Yeah, 0.2 series of it was the stable version till September. Then they released actually 0.3, but there is no actually new update. The same things, but only the few like let's say change they have done. But again, if you install this one and this one, I mean both will work in the same way. Okay, there is no change. Okay, if you see the documentation, there is no change. Okay, so that's why I was going through some of the documentation and I got to know. So this is the actually stable version of the Langchain right now. So 0.2.10. So this is the stable version of the Langchain right now. So we'll be installing this particular version. Okay, so this version we have defined. Apart from that, here we'll be also using something called OpenAI. Okay, OpenAI large language model. So for this, what I need, guys, OpenAI. Okay, OpenAI. But see, previously, I think you remember whenever we used to use older Langchain. That means if I go to the older Langchain, see, this is the older Langchain. Okay, this is the older Langchain 1 series. Okay, this is the older Langchain. So OpenAI was available inside Langchain only. Okay, if you only install the Langchain, you can also use the OpenAI from the Langchain. But currently, in the new change, they have created a separate library for OpenAI. So you have to install like that, Langchain, Langchain hyphen OpenAI. Okay, OpenAI. So this is the like package, guys. But again, I'm going to use one specific version, the stable version. Okay, this is the stable version. Then I'll be also managing my credential for the, let's say, OpenAI, or let's say if I'm using any other third-party API, so I also need the secret key. And to manage the secret key, I'll be using .env, okay, this particular file. So with the help of that, here I'll be mentioning all of my secret, so that whenever I'll be uploading the code in my GitHub, people won't be getting that particular file. Okay, so this is called actually python.env. So for this, you also need to install python.env. So this is the package we'll be also installing, python.env. Okay, and apart from that, to access that actually alternative model, that means open source model, we'll be using another library called Grok. Okay, Grok, and Grok is also available inside Langchain. Langchain has already created one framework called Langchain Grok. That means if you see the current Langchain, so all the things they have created separately. So if, everything they have been included in their root package. Root package you can use for the Langchain kinds of functionality, but if you want to integrate OpenAI, you have to separately install the Langchain OpenAI. If you want to use Grok, you have to separately install that Grok. Okay, that's how it is also having Langchain community. Okay, different kinds of Langchain library they are having, but it is using the same base Langchain only. But on top of that, they have created one separate library. Okay, this is the idea, because Langchain is a huge framework. If you see, it's a huge framework. So many, there are lots of functionality they have included. So that's why they have separated. These are the, let's say, different functions, so that they can do the organization of the code. Even as a developer, it would be easy for you to understand. Okay, let's say I need OpenAI, so I will be simply installing Langchain OpenAI. Let's say I need Grok, I will simply install Langchain Grok. That's it. Okay, so now see, I have specified my version. Now, if you share this project with anyone, okay, anyone, after 6 months also, they will still able to execute this project, because they will be also installing the same version, and whatever, let's say, code you will be writing on the basis of this particular version. Okay, that's why it is always recommended. I hope it is clear. But whenever you are not specifying the version, that means it will install the latest version. And whenever it will install the latest version, let's say if some functionality has been changed in the package, that time your code will break in the production. So now to install, these are the package, guys. What you have to do, open up your terminal and copy this command, pip install -r requirement.txt, and simply execute it here. That's it. So it will automatically install everything. So for me, I already installed. That's why it is telling requirement is already satisfied. But for you, it will take some time. Okay. Great. So that's how we can do the local setup, everyone. Now here, simply let's create one file. I'll just name it as file, let's say 01 talk with LLM.ipynv. Okay, so this is the file I'll be creating, and inside that I'll be doing the experiment. So let me select my environment. So Python kernel, so I need this LLM app, this one. Now if you want to test it, simply write a message. So see, execution is done. That means it's working fine. There is no error. All right. So now the first thing we'll be learning about how we can connect actually our this one, our actually most frequent large language model, which is nothing but OpenAI. Okay. And I think I already showed you the OpenAI playground. So it is having two kinds of model. One is the chat model, and there is the completion model. And I already showed you what is the difference between completion model and chat model. I think in the previous session, I already clarified. Okay. In the completion model, you can't pass any kinds of system prompt. That means it will generate something for you. But whenever I'm talking about chat model, it can also perform the conversation. Okay. Like a human. That means you can also give the system prompt, and you can select different model. You can see there are so many model inside chat model. But if you see, some few models are available inside this completion model. Okay. So first of all, let's try to see how we can load the completion model. Then I'll also show you how we can load the chat model, because Langchain supports each and everything. All kinds of model you can load. Okay. Great. Now I'll open up my, this is my notebook. So the first thing, guys, what I have to do, I have to add my OpenAI API key inside my environment variable. So let me add it quickly. So I'm not going to show you my key, guys. So let me just quickly add it. So in other screen, I'll just quickly add it, and I'll show you. So in my other screen, I will add it, because I don't want to show my OpenAI API key. Okay, I think you know how to create the OpenAI API key and how to set. So let me show you the key name you have to assign here. I think that would be clear. So first of all, you have to give the OpenAI API key. Okay. Inside this double quotation, you have to paste your OpenAI API key. So please go to your OpenAI account and try to create one API key here. And the second thing, I need the Grok. Okay, Grok API key. So as of now, I don't need it. I'll just try to comment it. So later on, whenever I'll show you the open source large language model, okay, we can access, that time we'll be using Grok API. Fine. Now let me copy paste my OpenAI API key quickly. So in the other screen, I'll do it quickly, just a minute. Okay, so I already set my API key, guys, all of you. So I'm not going to open this file, otherwise people will see my API key. You can create your own API key and you can paste it there. That's it. The first thing what I have to do, guys, I have to load this OpenAI API key. Okay. So to load it, you can execute this line of code. So here you can see, here I'm using python.env. So I think you remember, we install python.env. And with the help of .env, we can load any kinds of environment file. Okay, environment file. So here you can see I'm loading it. I'm using operating system package as well as the .env. And from .env, I'm loading load.env and find.env. So here you have to create one function of the load.env. Inside that, you have to mention this particular function find.env. That means automatically it will find this .env file inside your directory. Okay, and once it got, automatically it will load that inside my environment. And what I need, guys, I only need the OpenAI API key. I don't need anything else. Okay, if I open my, let's say this one .env, I think, let me show you. So enter key is not visible. See, I only need the OpenAI API key. I also set my Grok API key, but as of now I only need the OpenAI API key. That's why here I'm calling I only need the OpenAI API key. Okay, and I'm storing inside the variable. That's it. Now let me execute. See, successfully executed. That means it has successfully loaded my API key. Okay. Now before starting with our connecting with large language model, let me show you the list of the model can support like Langchain. Langchain can actually load all kinds of large language model. You can see this is the list of the large language model. If you open the Langchain documentation, okay, you can see this is the newest Langchain documentation. So here they have already mentioned inside LLM, it can also load AI2I large language model, Aleph Alpha. Okay, see, then different large language model you can see. Okay, so 100 of large language model it can load. So let me show you the OpenAI. See, OpenAI also it can load. It can also load the Meta, Llama. Then it can also load the Mistral. Okay, all kinds of model it can load. It is also support Grok API. So everything it supports. Got it. So if you want to see them, you can open this particular link and there you can see that. So let me add this link as well in the notebook. So here I can mention. Here I can mention. Okay. So this is the documentation. If you open the documentation, you will see that all kinds of large language model your Langchain can support. Got it. So that's why we call it as a universal framework. That means it can support any kinds of large language model, any kinds of tools and technology. Okay. But if you're not having the Langchain, that times we need to separately learn. Okay, let's say I want to load OpenAI model. I also need to learn the OpenAI framework for that. Okay, this is the main issue. It can also support Hugging Face. Okay, you can see Hugging Face model it can also support. Okay, great. Now let me open the this one actually our OpenAI model. So I already told you OpenAI is having different kinds of model like chat model as well as the completion model. So first of all, we'll try to learn how we can load the completion model. So let me just comment here. So this is what completion model. Completion model. Okay, to load the completion model. So first of all, import the OpenAI from the Langchain. Just write from Langchain, Langchain OpenAI. Okay, Langchain underscore OpenAI. I want to import OpenAI. Okay. Now let me create a wrapper. I'll just write LLM model. And here I'll just specify the OpenAI. Okay, that's it. Now it will by default, okay, it will by default load one completion model. Okay, you can also give the model ID here, but I want to load the default completion model. Now see if I execute, it will successfully load the model. And if you want to see the model configuration, you can also print this particular variable. See, this is the entire model configuration, but this will give you as a object. Okay, as an object actually it will provide you. So let me comment. So this thing I don't need. Now let me first of all show you how we can interact with this particular model. For this, what you can do, you can use one a function from this object called invoke. Okay, with the help of invoke, you can send the prompt. Let's say here I'll give one prompt. So let's say this is my prompt. Here I'm asking, tell me one fact about Kennedy family. Okay, if you don't know Kennedy, so let me search on Google. So you can see John F. Kennedy. So John F. Kennedy was an American politician, okay, who served as 35th president of the United States. Okay, so here I'll be asking the question related this Kennedy. Okay, Kennedy family. So here is my prompt, guys. You can see, tell me one fact about the Kennedy family. Okay, now see, if I execute, it will give me one response. Now you can see this is the response I got, but I'm directly printing the response. So I can also store it in a variable. So the variable name I'll give response. Okay, response is equal to my LLM response. Okay, whatever response actually I'm getting. That's it. Now let me execute it again. Okay, now you can simply print this particular response. So print response. Now see, this is the response I got from my large language model. And see, this model is about actually this model, completion model. Okay, completion model. Got it? That means it will generate something for you. You can't perform the conversation with that model. Okay, conversation kinds of functionality you won't be getting in the completion model. I think I already showed you the dashboard. Okay, the playground. Now see, this is the output I'm getting. It's a one-shot output. Directly it is giving me the output. But whenever, let's say I'm opening ChatGPT. Let's say if I go to the ChatGPT, and if you give any kinds of prompt, let's say here if I give, I'll give the same prompt here. I'll copy. Sorry. I'll copy this prompt. And here I can ask. Now see, it will give me streaming output. See, it is a streaming output. See, it is streaming, right? So after one word, another word is coming. After one word, another word is coming. Okay, it is called streaming output. So can I also generate this kinds of streaming output? Yes, we can also generate. For this, we can use this particular syntax. So simply just write one for loop. So I'll just write a for loop. So for chunk, okay, chunk in LLM model dot, there is a function you have to use called stream. Okay, stream. Now inside that, you have to ask the prompt. Let's say whatever prompt I have given now. So let me give the same prompt again. So this is my prompt. Tell me one fact about Kennedy family. And this is a for loop. So it will have one indentation. Okay, now here I will print this one actually. Print the chunks. Then I will also need to give some parameter. So I'll give another parameter called end. End is equal to empty. And there is another parameter called flash. Okay, flash is equal to true. Now see, if I execute this code, you will see that I will also get streaming output. See, streaming output I got. So I think it was not visible. So what I can do, I can give any other prompt. Let's say I need detail response. See, it is streaming. See, it is streaming. Okay, I'm executing in the VS Code. That's why you can see it is streaming in this way. But if you're executing in that terminal, okay, inside your terminal, you'll see that it will give you streaming output. So let me also show you. Maybe I can create a file here or demo.py. So inside that I can execute the same code. This code I'll try to execute. Okay, now let me execute the file and let me show you. So Python demo.py. Now see, you will see that streaming output. See, it's a streaming output. Okay, like the ChatGPT. I hope you got it. And if you see the previous example, it will give you one-shot output. So now let's say you want to create an application and it will look like a ChatGPT, because streaming output, it looks good whenever it will generate the response. It is feel like it is generating real time. So that's why most of the application will be using streaming output. Fine. Now you can also set some configuration of your model. Okay, so let me show you. If I go to the playground again, see, it is also having some configuration. If I go to the completion model, see, it is also having configuration like temperature, maximum length. Okay, so these are the parameter you can also set. So you can set from the UI also. You can either set from the Python code. And if I want to set from the Python code, guys, what I need to use this particular syntax. So let me again initialize the model. So here I will initialize the model. So let's say this is my updated model right now. And inside that, you can pass any kinds of parameter. Let's say I'll give the temperature parameter. So temperature I will give 0.9. Temperature is a creativity parameter. Okay, it's a creativity parameter. So temperature more or less you can give. If you are giving more, that means it will be more creative. If you are giving less, it will be less creative. Okay, I hope it is clear. So here I can write like that instead of, so creative model. Okay, now this is my creative model, because you can see I have initialized 0.9. Okay, 0.9 as my temperature parameter. Now see, if I show you the response right now from my large language model, so I will execute the same line of code. Here I can execute this line of code. Okay, so tell me about, now I'll be using this creative model. Okay, now you'll see that the response would be more creative than your previous one. Okay, now you can see the response would be more creative than your previous one. You can also give any other, let's say, prompt. Let's say I'll give, write a short 5-line poem about JFK. Okay, that means Kennedy. So you will see that it will give me the poem. So I can print it. So this is the point I got. And now see, I think you remember, if you are using previous older version of Langchain, whenever you will execute this code, you will get one warning here. Okay, deprecation warning. You will get deprecation warning. Now see, here I'm not getting any kinds of deprecation warning because we are using latest version of the Langchain. So this is all about our completion model. Now let's learn about chat model. Chat model. Okay, so I think you remember we are also having chat model. So different kinds of chat model, and the recent model they published called GPT-4o mini. So I'll also tell you how we can use this model as well. So first of all, let's use GPT 3.5 turbo model. Okay, we'll be using turbo model. So if you want to see the list of the chat model, you can open the documentation. So these are the documentation actually it is having. So they're also telling that's how you have to load this model. Okay, so create the chat. You need to use chat OpenAI function, but previously I was using this one. OpenAI only, but if I want to use chat model, I need to use chat OpenAI. You can see chat OpenAI. Inside that you can specify the model as well as the parameter. Okay, and you can see different kinds of chat model documentation they have already given. And again, I told you this Langchain documentation is not very organized. So if you are going for the first time, definitely will get confused. Okay, so first of all, try to see whatever I'm doing, then you can go to the documentation, then it would be clear for you. Okay, so now let's try to use the chat model. Now, as I already told you, if I want to use chat model, so I have to use this particular syntax. So from Langchain OpenAI, I have to import chat OpenAI. Inside chat OpenAI, you can specify the model. Let's say I want to use this GPT 3.5 turbo. Now you can simply go to the OpenAI model list. So OpenAI models. Okay, so you'll see that list of the models you will get from the OpenAI. So you can see this is a 4 series, but I'm using 3 series actually. GPT 3.5 turbo series. So we go below GPT 3.5 turbo. So here I'm using this model actually, GPT 3.5 turbo 0125 model. You can see this is the model actually I'm using, 0125 model. Got it? Now let me initialize the model. Now see, whenever I'm using chat model, so chat model can take how many input, guys? I think you remember, if I go to the playground, it can take 2 input. One is the system instruction, other is the user instruction, user prompt. Okay, you can give any kinds of system prompt, you can also give any kinds of user prompt. So here also we can pass the same thing. So let me show you how we can pass. So this is the syntax. So first of all, you just need to create one list. Inside list, you need to create one tuple. Okay, inside the tuple, here you can see I have given the system. That means this is the system instruction. And this is the system instruction I'm giving. You are the historian expert in Kennedy family. And this is the human prompt. Whatever prompt actually we are giving, this is the human prompt. And this is the prompt I have given. Tell me one curious things about JFK. That means Kennedy family. Okay. Now, simply again, you can use the same function, invoke function, and inside that you just need to pass the message. Now, see, if I execute, you will get the response. Okay. So if I show you the response, see, this is the response. Okay. Now, if you only print the response, you will see that it will label like a AI message. Okay, it will label like AI message. Let me show you. So I can give the same prompt here. So I'll copy I'll give it to the system instruction, and this one I will give it to the human instruction. Okay, now if I execute, see that as a user, actually it has taken my prompt. Now assistant. Okay, so ChatGPT will give you user and assistant, and whenever you are using Langchain will take as an AI message. That means whatever response actually it will give you as an AI message, and whatever response you are giving, it will take as a human message. Okay, I hope it is clear. So this is the labeling it usually do. Okay, now from the AI message, what I need, guys, I need the content, because see, inside content I'm having my response, right? Now if you want to extract the content, simply you just need to write response.content. Okay, response.content. Now if I execute, it will only give me the content right now. Now if you also want to see the metadata, you can also see the metadata, like how many tokens it has given you. Okay, how many prompt token, how many total token, how many completion token, all the metadata it will also provide you. Got it? And if you want to see the schema, you can also print the schema as well. So it will show you the entire schema. Like you can see title AI message, and this is the message it has given you. Okay, this is the entire schema. But only I just need the content. Okay, whenever you will be sending any request to the large language model, so you need the content as an output. Going forward, we'll be learning also Langchain expression language. There I'll also show you one amazing, actually, let's say tools we are having called output parser. Okay, with the help of output parser, we can automatically get our response, okay, without any kinds of object. So this will I'll also show you how we can do it. And now you can ask me how we can load this GPT-4o model. Okay, simply you can load this GPT-4o model. So let me give you that idea as well. So you just need to use this line of code. So let me comment. See, where you will see this other model, here you just need to change with this model, actually GPT-4o mini. That's it. Now if you execute this line, it will load that model for you. Okay, see, it will load that model. Okay, now we can try. So I'm not going to execute the model, guys. Now after the session, you can try with GPT-4o mini model as well. Okay, now if I'm talking about previous Langchain, guys, the older version of Langchain, old Langchain. So people used to write the syntax like that. So first of all, they used to import these are the library human message, system message, okay, and chat prompt template, and they used to pass like that. See, system message, that means if you want to pass the system message, you have to pass is inside this particular function, system message, okay. And if you want to pass the human message, you have to pass inside human message function. You can see the human message actually I'm giving. Okay, then whatever response you are getting, you are again storing to the response. But in the updated version, what they did, instead of using these are the functionality, you can directly pass here. You can directly pass as a list. Okay, you can directly pass as a list. Multiple prompt you can pass inside a list. You don't need to use these are the function again and again. Okay, that is the main advantage you will be using in the latest version of the Langchain. So these kinds of small modification, guys, they have only done. Okay, and rest of the concept will be remain same. Whatever logic you have learned in your previous Langchain also, it will remain same. I hope it is clear now. You see, if I execute this line of code as well, it will give me the same response. Okay, so this is the older syntax. Now let me show you the alternative. So what I can do, I can just write alternative LLM. Okay, so for alternative LLM, here we'll be using one API, free API called Grok. So let me open this Grok website. So let me also give you the link. So go to playground. So here I will also mention the link so that you can also log in with. And make sure you create one account first of all in the Grok. Okay, if you create one account, so you'll get this kinds of window. Now the first thing what you have to do, you have to generate one API key. Just click on the API key and create one API key here, guys. So for me, I already created one API key, and this API key I already set inside my environment. You can see. So this API key I already set inside my environment. See, here I have already set. Okay, now I'll delete it after the session. Otherwise, people will be using my API. Don't use my API, guys. This is completely free. Just try to open up your account and try to create one API key. Okay, after creating, just try to paste inside your .env file, and you can see this is the playground. That means you can select different model. Let's say I want to use this llama. Let's say I want to use this model, actually llama 3.1, this model. Okay, this model I will select, and here you can give the system prompt. So I'll give the same system prompt. So let me go to my notebook. So I'll copy, and here I can paste, and then I will also give my human input. Okay, now simply if I submit, it will give me the response here. Okay, this is the response I got. The same way, whatever way actually we used to use ChatGPT, the same way you can use, but this is the free one. Okay, alternative one. Now with the help of Grok API, we'll be accessing different kinds of model. You can see we can access Jima model, we can access Llama model, Distill Whisper model. Okay, then we are also having Mistral model, Lava model. So all kinds of actually, not all kinds of actually, but some of the very good model are available inside this Grok API. Okay, and you can access through the API request. This is the main advantage. Now let me show you how we can access it. So we already installed the Grok here. You can see Langchain Grok we already installed. Now simply just load your environment again, because it should load your Grok API. It will load your Grok API. Okay, automatically it will load your Grok API. Okay, then after that you have to use this syntax. So from Langchain _ Grok chat Grok. Inside chat Grok, you need to give the model ID. Okay, you can see I'm using Llama 3 7B 8192 model. Okay, you can see here this model is also available, I think, somewhere. See this model, I think. Let me show you. 7B 8192, 7B 8192, 7B, yeah, 8192. So this model actually I'm using. You can also load any other model. You can also load Mistral model. Mistral is also having. You can also load the Mistral model. I'll also show you how we can load the Mistral model. First of all, let me load this model. Okay, so this is the Llama model. And if I want to load the Mistral model, simply give the Mistral model ID. See Mistral X 8X 7B 32768. So if I show you, so this is the model. Mistral, this model actually I'm loading. So any kinds of model you can load. Just give the model ID, that's it. Now see, both model I have loaded. Now again let me pass the prompt. And how to pass the prompt, guys? Because this is a chat model. Again I have to pass as a list. The same thing we did in the OpenAI. The same thing we have to follow. First of all, I have to give the system prompt, and I have to give my user prompt. Okay, again I'm giving the same thing. You are the historian expert in Kennedy family. How many members of the family died in tragically? Okay, now if I execute, then now I'll pass this prompt inside my LLM. So chat, I'm first of all using Llama model, llama.invoke. I'm giving the message, so it will give me the response. So you can see the response content. See, okay, amazing content we got. Now we'll also use this one, Mistral model as well. So let me also show you the Mistral model. So Mistral, I'll give the message, and this is the Mistral model response. Okay, and see the execution time is very, I'm very fast here. Okay, very fast here. But if you are downloading these are the model from the Hugging Face and you are executing in your local machine, you won't be able to do it. Okay, you need a good configuration machine at the end. Okay, now see guys, this thing is very important, because going forward, whatever things we'll be doing, we need the large language model. Either we'll be using OpenAI model, either we'll be using, these are the alternative model. So both I have showed you. Now if you have OpenAI account, you can use OpenAI model. And if you don't have a OpenAI account, you can also use, these are the model. Okay, Grok API you can use. Based on that, we'll be learning prompt template, chains, output parser, okay, RAG. So these are the different things we'll be learning inside Langchain. Because many people will get confused. Okay, how we can access these are the model. Okay, what is the technique we can access? So this is what I just wanted to show you today. And this should be our foundation. With the help of this foundation, we'll be working later on. Okay, everywhere, whatever example I'll show you now, everywhere, this thing I don't need. So everywhere you'll see that I will be using this syntax. This syntax actually will be mostly using chat model, not the completion model, because nowadays people are using chat model. Completion model people are not using, it is deprecated. Okay, you have to use the chat model most of the time. So we'll be using chat model most of the time, whether I'm using OpenAI model or whether I'm using any other model. Okay, we'll be using chat model most of the time. Next session, we'll be learning about the prompt template in detail. What is prompt template? What is chains? And what is output parser? Okay, then we'll be also moving to the new concept of the Langchain. So guys, now we'll be learning about prompt template inside Langchain. Because I think you know, if I want to use large language model, I have to pass the prompt. Okay, and to pass the prompt, I have to follow some specific template. So this is called prompt template. So with the help of this prompt template, we'll be integrating all the logics. Then we'll be passing this logic into our large language model. So let's try to see some practical demo of this prompt template. then I think this part would be more clear. So first of all, let me start with the prompt template. Okay, prompt template. So see, as of now, I think we already saw if I want to work with the large language model, so what I need to give, definitely I have to give the prompt. So prompt is everything inside large language model. Okay, that means prompt is nothing but, so prompt is nothing but it's a I mean programming language. You can talk about it's a programming language for LLMs. Okay, to perform communication. Okay, so this is called prompt. And now what is prompt template? Prompt templates. Okay, so prompt template is nothing but it's a template. Okay, template means, so here you can pass any kinds of variable. Okay, you can pass any kinds of variable during execution of your code. That means during runtime of your code, you can pass any kinds of variable as an input. Okay, that means you can create a template here. It's not like that you need to always directly pass. Let's say this is my large language model, LLM. Okay, so let me just write, this is my LLM. Okay, so it's not I mean always it's not actually necessary to give the prompt directly. Okay, so you don't need to give the prompt directly as a hard coded. Okay, and you don't need to get the output. Sometimes what you will be doing, you will be creating a template. Instead of giving the hard coding prompt, you will be creating the template so that user can give some input, okay, in real time. And this input actually will change actually real time inside the prompt template, and this prompt actually will be passing to the large language model. So let me show you one example. Let's say let's say I want to design a prompt. Let's say tell me about dash. Okay, tell me about dash. So here I can pass anything. Let's say tell me about India. Okay, then I can also pass tell me about, let's say JFK. That means Kenny's family. I think you remember I was giving some example. So yeah, Kennedy family. Okay, Kennedy is actually president of United States. Then I can also pass tell me about, let's say, Tesla. Now you can see this particular prompt is remaining same everywhere. So let's say this is my first prompt, this is second prompt, this is start prompt. So in three prompt actually you can see this part is common, okay, for all the prompts, but here it is only changing. Okay, this part actually it is changing. Okay, this part is changing. So what I can do, instead of, let's say, creating multiple time, okay, this prompt, I can create a template. That means I will create like that. Let's say tell me about, so it would be dash. Okay, so here I'll take the input from the user. Okay, here I'll take the input from the user. That means whatever input user will give me, let's say input is equal to, let's say, India. So what will happen, this input will go to this particular, let's say, curly brackets. I think you learn about f string inside Python, yes or no? Inside f string also we used to pass the input like that. If I want to take any input real time from the user, and if I want to, let's say, modify this particular string, that time I used to use f string. So this is the similar kinds of f string only. Okay, so here we will be creating a template. Instead of passing that direct prompt, you will be creating a prompt template here. And if someone is giving any kinds of input, this input you will be accepting, okay, and you will be passing it to the template, and this template will create the entire prompt and will pass to the large language model. Okay, then you will be getting the output. So I'll show you some example. After getting the example, it would be more clear. Okay, so let me open up my what I can do. I can open up my code. So this is my VS Code. So here I'll create a file. I'll name it as 02 talk with LLM part 2. I can give part 2, you can give any name. Let's give part 2 only, YNB. So here, first of all, I'll be selecting my kernel. So I think you remember we created this LLM app, okay, this particular environment. Okay, so the first thing guys, what I have to do, I think you remember, first of all, I have to load my environment, okay, environment file, because inside that I'm having my OpenAI API key and Grok API key, right? So either you can load your OpenAI model, either you can load any kinds of Grok open source model. So I already showed you both of the example. Now, if you don't have the OpenAI account, you can load the Grok model. That means any kinds of open source model, you can load Llama model, Mistral model, it's up to you. Either you can load the OpenAI model if you already have the OpenAI account. So for me, I already have the OpenAI account. I'm going to open up my, I'm going to load my OpenAI model. So for this, I'm going to open, let's say, load this particular OpenAI API key. Okay, you can see I'm loading the OpenAI API key with the help of load env package. Okay, so I'm loading it. Then after that, what I need to do, guys, I'll be loading my large language model. And how to load the large language model? So first of all, I'll load my this model, completion model, completion model. Okay, so what is completion model? Completion model is nothing but it's a simple LLM model. I think I showed you the difference between completion model and the chat model. So I think you remember. So if you don't remember, let me again show you. So you can open this playground of the OpenAI. So this is the playground, guys. So here you can see, guys, you have the completion model. Okay, completion model. So it will only do the completion operation. Let's say if you give anything, it will complete that particular, let's say, sentence, or let's say story, whatever. So here you can't perform the conversation. Okay, conversation kinds of things you can't perform here. But whenever I'm talking about chat model, here you can perform conversation. That means it will work as an assistant. That means here you can pass the system instruction as well as the user instruction. Both you can pass. Okay, so this is what actually you have to remember always. So we are having two kinds of model. One is completion model, and that is like chat completion model. So most of the time we'll be using chat completion model, because nowadays whatever large language model you can see in the market, all the model has trained with the chat completion model. That means with the help of that, you can perform the conversation, and you can also perform different kinds of tasks. Got it? So first of all, let me show you how we can create the prompt template for the completion model. Okay, first of all, we'll be learning the completion model. Then I will also show you how we can perform for the chat completion model. Okay, both will be exploring one by one. So first of all, let me load the completion model. And if I want to, first of all, I'll be loading the completion model. And if I want to load the completion model, this is the syntax from Langchain OpenAI. I'm only importing OpenAI. Okay, and it will load the default model. I think Babbage 003 model, it will load. I'm not sure, but you can see, check the documentation. So in the documentation, they have already written, okay, which model actually they will be loading. Apart from that, I also need to load my chat completion model. So let me also comment here, chat completion. Okay, chat completion model. So this is the syntax to load the chat completion model. So here you just need to import this particular function called chat OpenAI. Inside that, you can give the model ID, which model you want to load. So here I'm loading the GPT 3.5 turbo model. Okay, I already showed you the model list. Inside that, you can select any kinds of model. It's up to you. So both model, I'll try to load it. Then first of all, I'll show you how to create the prompt template. Okay, let me comment here. So prompts and prompt templates. Okay, so this is what actually we'll be explaining here. Okay, now if I want to, so let me just delete this one. It's not required. So if I want to create a prompt template, so I need a function from the Langchain. So just try to import Langchain underscore code dot prompt. Okay, prompts. So here you need to import prompt templates. See, the prompt template actually I'm creating, this is for completion model. Guys, try to remember. Let me just comment here. This is for completion model. Okay, completion model. So for completion model, you have to import this particular function called prompt template. Okay, now let's create the prompt template. So here I'll just take a variable called prompt underscore template. Okay, prompt template, and there is another function you will get called from template. Okay, from template. Inside that, you have to pass the prompt. Let's say here I'll give one prompt. Tell me a let's say you can give any kinds of, let's say, variable name. I'll give, let's say, adjective, story. Okay, story about a certain topic. So here I can mention this variable name as a topic. Okay, that means these two would be input from the user. So user can give any kinds of input in this actually bracket. Okay, you can see this is the variable I'm taking called adjective, and this is the variable I'm taking called topic. That means if you complete this particular, let's say, prompt, let's say tell me about, tell me a curious story about Kennedy family. So this will become a complete prompt. Now you can pass any kinds of input, okay, based on your choice. Okay, what kinds of, let's say, story you want. Okay, you can modify here. That is what actually we call it as a prompt template. Instead of hard coding them, what I'm doing, I'm creating as a input. I'm creating as a variable so that user can pass the input and they can get the response from the model. Okay, this is what actually we are doing. Now this is the template we have created. Now how to, let's say, pass the input. Okay, how to pass the input inside the prompt template. For this, let me create an object. I'll just create object LLM model prompt is equal to, so prompt template dot format. Okay, format. So if you have already learned the Python, guys, if you have learned the string, I think you know what is format, dot format, what it does usually. Okay, so inside dot format, I'll pass, these are the value one by one. So let's say adjective is equal to, I'll give curious. Okay, curious. And topic is equal to, let's say, I'll give the Kennedy family. Kennedy family. Okay, now you can give any kinds of input. It's up to you. Now if I want to pass to the large language model, what I'll do, guys, I'll call my large language model. So I'll call my completion model. Okay, not the chat completion model. So completion model is my LLM prompt. Okay, LLM model prompt. Now see, if I execute, it should give me the answer. Okay, see guys, it is the answer. You can also store in a variable. Let's say I'll store in a response variable. And now you can simply print this response. See guys, this is the response I got. So that's how we can create a prompt template for the completion model. Now see, here I can give any kinds of input. Let's say I can give the topic anything. Let's say I can give Tesla. Okay, Tesla. Now if I execute, see, it will tell me about the Tesla. Okay, curious story about the Tesla. See, okay. Now see, as a user, okay, let's say as an user, I can pass any kinds of input. Now I have the flexibility here. But previously, what I used to do, I was to pass the prompt directly. You can see, I was to pass the prompt directly. That means hard coding. I was hard coding. Let's say I want to change the prompt. What I need to do, I need to come here. Inside that, I need to change the prompt. Okay, but here I created a template. That means this will be my structure of the prompt. And now we can pass any kinds of input. Okay, wherever actually we are creating this particular bracket. That means whenever we are creating this particular template. Got it? And here you can pass any kinds of input. So let's say whenever you will be creating any kinds of web application, that time you can take the input from the user and you can just replace here that variable. Okay, this is the idea. And this is what actually we created for the completion model. Okay, if you are using completion model, that time you will be using this template. Now I'll be discussing about the chat completion model. Okay, how to create for the chat completion model. But mostly you will be using chat completion model, guys, because I already told you all the models. Nowadays you will see the chat completion model. Okay, not the completion model. So now let's see how we can create for the chat completion model. Okay, for chat completion model, so again you need to import one function from the Langchain core. So Langchain core dot prompts. So I need to import chat prompt template. Okay, this is the function, guys, chat prompt template. And the previous word I imported called prompt template. Now this is what actually called chat prompt template. Okay, this is the different only. Okay, let's try to remember. Now let's create the chat prompt template. So here I already created. So let me show you how it will look like. So this is the prompt template, guys, I created. I think remember whenever I was using the chat model. So here let me show you the chat model example. Yes, so this is the chat model example. So here I can pass the prompt. How many prompt I can pass, guys? I can pass two kinds of prompt. One is the system prompt, one is the user prompt. So if I go to the playground, I think remember, I can pass the system instruction, I can pass the user instruction. Okay, that means two prompt this particular chat model can support. Chat completion model can support. Okay, so that is why I was passing this two prompt. I think you remember here. I was passing this two prompt. One is the system prompt and this is like our user prompt. That means human prompt. Okay, now here you can see I'm passing the same thing. First of all, I'm giving the system. Okay, system instruction. That means system prompt. So here I'm writing you are an profession. Okay, profession is my variable. That means it is my input variable. Now user can pass any kinds of, let's say, input here. Let's say here user can pass you are an let's say history. Okay, historian. Let's say historian expert on the, let's say, Kennedy family, or let's say Tesla. Anything user can pass. So profession wise they can pass, let's say, historian. Topic wise they can let's say pass Canadian family, or let's say Tesla. Okay, whatever, let's say, input user want to give, they can give here. No need to worry. Then human. So human, let's say this is the human prompt I am giving. Hello, Mr. Let's say historian, or let's say anything you can give, anything you can call. And can you please answer a question? Okay, let's say this is the question human is asking. Then again, AI is giving me the answer. Let's say AI, sure. Then human input. That means here I'm passing few short prompt. Okay, I think you remember, guys, inside prompting, we are having some kinds of prompt. So let me just write down. So I'll be also discussing this prompt engineering later on. So there actually you'll get the idea. So here I can, let's say, give prompt engineering. Okay, prompt engineering. Inside prompt engineering, you are having some types of prompt, like you are having zero shot prompting. Okay, zero shot prompting. You are having few shot prompting. Okay, few shot prompting. So here I'm passing few shot prompting. That means I'm giving few shot. Okay, few shot. That means my model will try to understand, okay, I want to do a conversation. Okay, conversation with the large language model about the this particular, let's say, topic, this particular profession and this particular topic. Okay, and this topic, this profession and topic will I will get input from the user. Okay, this is the idea. Now let me show you how we can pass this. So this is the code. So here you can see I'm calling the chat template, then format masses. So profession is equal to I'm giving historian, topic is equal to I'm giving Kennedy family, and this is the input. I'm asking how many grandchildren had Joseph P. Kennedy. That means how many children, okay, he was having. So this is the question actually I'm asking, because I already told my large language model you are an expert historian about Kennedy family. That means it will only give me the Kennedy family related let's say response, because I already given in the system instruction. Okay, system prompt. Okay, this is called actually chat completion model. That means you have the flexibility. You can give the model, okay, as a power to a specific topic. Okay, I think it is clear now. Now, if I want to pass this message to my large language model, again, I'll call the same thing, chat model.invoke. Now, see, I'm calling the chat model, not the LLM model. Okay, I'm calling the chat model. So chat model.invoke. Inside that, I'm passing this particular message, the prompt template I created. So this is going to be my entire prompt template. Now, see, if I execute, and before that, I will also print the response. Okay, now see, if I execute, it will give me the answer response. See, guys, this is the response I got. Okay, this is the entire response I got. Now again, you can see it is giving me content. So if you only need the content, you can call like that. So I only need the content. Now see, it will give me the entire string. Got it? So this is what actually we can do in case if I want to create the chat completion model prompt template. And this approach actually will be using a lot. Okay, with all kinds of actually chat model. And let me show you how people used to do in the older way. So old way to create the prompt template. See, this is the snippet I collected over the internet. See, this is the old way to create the prompt template. So first of all, you have to import system message from the Langchain core message and prompt human message prompt. Now you'll be creating the chat prompt template, and here you have to pass as a system message. That means the system instruction I was to pass. Now this one, okay, I have to pass inside this particular function, system message. You are an historian expert on the Kennedy family, and they used to give as a hard code. Okay, you can see it's a hard coded, let's say, prompt. Then as a human, whatever human message actually you want to pass, you have to pass inside this particular function called human message prompt template. That means this one. Okay, this one you have to pass inside that, and whatever input user will give, that means this input. Okay, so you have to pass it here. Now this is the input, guys. The name of the children of the Joseph Kennedy family. Okay, now see, if I execute, it will give me the output. It will also work. There won't be any kinds of issue, but again, this is a older approach, and you can see this approach is a little bit what I can say, confused to understand. Okay, if you see, it's like more tricky, so you have to use some external function for this to create the prompt. But if I'm talking about this one is like more easy to understand. Okay, so inside this list you can pass the multiple tuple, and you can simply create the format, and you can pass this particular format to the large language model and it will give you the output. But here in case you have to use so many functions and you have to prepare the prompt. Okay, this is not actually good way to define the prompt. So if you want to print the content, so simply you can write like that. So see, this is the entire content you will be getting. Now let me show you another few short prompting example, how we can create. So inside Langchain code prompt, I am having one function called few short prompting. Okay, see, most of the time you will be using this approach actually instead of this approach. Okay, this approach, you can use this approach if you want to create the few short prompting. So you can see few short chat message prompt template. Okay, now inside that, first of all, you have to give the example. So this is the example. So here I have given some example. Let's say input hi, output hola, then input by, output, let's say adios. I don't know how to spell this, but this is a Spanish. Okay, Spanish actually, let's say a sentence. Okay, Spanish, let's say language. That means here I want to create a language translation. Okay, language translator. So that is why I'm giving some few short prompt to my large language model. I'm telling, so if user is giving any kinds of English sentence, you have to convert it to the Spanish. Okay, so that's why I'm giving some few short. You can see two input I have given. If it is more than one, that means it's a few short prompting. Got it? So this is the example. Then after that, I'll create one chat prompt template here. So chat prompt template from message. So user will give the, okay, let's say as a human, you will give the input and AI will pass you the output. So this is the structure you are creating. Okay. After that, you have to prepare the template. So for this, you can use this particular syntax. So few short prompt template. Inside that, first of all, you will be passing the example prompt. Okay, the example prompt you have created. Then you have to also give the example. That means your model will try to understand, okay, so user will give me the output, input, and I should return the output. Okay. And what kinds of, let's say, task you want to perform? You want to perform these kinds of tasks. That means if user is giving any kinds of English text, I have to convert it to the Spanish. Okay, so it will be learning from the few short prompting. Okay, this is the idea. Now let me create my final prompt. So to create the final prompt, you have to use this particular syntax. That means chat prompt template from message and system instruction. First of all, you have to give, I think remember chat model text as system instruction. So this instruction you have to pass. So you are an English Spanish translator, and then you have to pass the few short prompting. The prompt template you have created, you have to pass it here. Then whatever input user will give, this input actually will be passing it here. Okay. Now you can ask me how we can pass to the large language model. Okay. How it can be passed to the large language model. For this, you have to use one amazing, let's say, technique called chain. Guys, now we'll be exploring the chains inside Langchain, because inside Langchain, chains is everything. With the help of chain, actually, you'll be executing all the action. So we'll see this chain in detail. For this practical demo would be better. So let's try to see some demo. What is chains inside Langchain and how it works. We'll be learning about chains right now. Okay. So with the help of chains, actually, we'll be executing this particular prompt template. And what is chains? Chains is nothing but it's a let's say actions. Okay, executable actions. That means it's a step of execution. So first of all, which chain would be executed? So I think you know inside Langchain everything is all about chain. So let me just open up my Blackboard. Let's see. Whenever you are talking about Langchain, so here everything is a chain. Let's say whenever you are preparing the large language model. So this is one executable. Okay, executable. Or you can also call it as runnable. Okay, runnable. That means it can execute. It can execute itself. But if I want to execute the large language model, what I need, guys? I need the prompt. Okay, I need the prompt. So this prompt I will pass to the large language model. Large language model, what it will give me? It will give me some response. Okay, response. Or output, you can also call it as output. Okay, output. Then with the help of output parser, we can format what kinds of output I need from the large language model. Okay, so these three things is important. So one is the prompt, one is the large language model, another is the output. That means output parser. Okay, so if you have these three things, and if you can create these three at least chains, you'll be able to execute any kinds of large language model. Okay, let me show you one example what I'm trying to say. So here what I can do, I can copy the same example, and here I can paste it. Okay. Now see, this is the chains, and this is the latest Langchain syntax, guys. Previously, we used to use the chain function from the Langchain, but nowadays you will be using this particular syntax. So first of all, take a variable. You can take any name. I've taken chain. Then first of all, you have to give the prompt. Okay. So prompt, where it will go to the large language model. Okay. So you have to give this pipe symbol. Pipe means this is the chain. You are creating the chain. That means after this executable, okay, your LLM executable will start. So LLM, so not a LLM model, it's a chat model because I'm using chat model. Okay, now see what is happening. First of all, your prompt would be executed. That means whatever user will give, let's say user has given, let's say how are you. So what will happen? Your model will get how are you sentence, and this how are you sentence will go where? It will go to the large language model. Okay, so large language model take this input and it will give you one output, okay, which is nothing but your output. That means the response, and this response I can also format with a specific, let's say type. Let's say I want to get the JSON output, I want to get, let's say, text output. I can also give the format with the help of output parser. I will tell you about the output parser. As of now, I'm not telling you about the output parser. I'm only telling you how we can create the chain. Okay, how it create the chain if I want to execute my prompt template. This is the idea. Now see, if I now execute chain dot invoke, okay, chain dot invoke, and here I think remember user will give what? User will give the input. So inside that you have to pass the input. So input. So make sure it should be a dictionary. Okay, so here you can pass any kinds of input. So I can pass, let's say, how are you? So let's say this is my input. Okay, now see, if I execute the program, it will give me the response. See, this is the response, and this is the Spanish of the how are you. This is the Spanish of the how are you. Now let's say I only need the content. In case, what I can do, guys, I can store inside a variable called response. Okay, and this response I can print simply. So print response dot content. See, this is what actually I'll be getting. And if you want to see the entire response, this is the response. This is the entire response. Okay, you can also see the metadata and all, like how many tokens it has given you, every information actually it will also show you. Got it? So this is called chain, simple chain, and no need to worry. I'll discuss the chain in detail. And this is what actually your this one actually Langchain expression language syntax. Okay, the syntax we have written, this one, this is called actually Langchain expression language syntax. That means this is the newly, whatever, let's say, updated Langchain you can see. So people are using this particular syntax, but previously we used to use something called chain. Okay, chain function from the Langchain, but nowadays we don't use that. We create this particular, let's say, pipe symbol. Okay, with the help of pipe symbol we define this is nothing but my chain. That means after this prompt my model will be executed. That means whatever prompt user will give, this prompt would be executed inside the model. Okay, this is a step of execution. I think it is clear. A very important concept, guys, because this is the basic. Okay, whenever I'll be discussing about Langchain expression language in more detail, that time this concept will help you a lot. Just try to, understand, okay, what I'm trying to say. I'll discuss in more detail what is Langchain expression language. I'll also show you what is runnable, what is, let's say, like executable, different things I'll show you inside that. Okay, so then this part would be more clear. As of now, I only showed you the simple syntax, how we can create the chains, okay, with the help of pipe symbol. So that means what is happening. So let me open up my Blackboard again and let me explain. See, I think you remember. So here we created what? We created this particular prompt template. That means as a system instruction I have given, you are an English Spanish translation, and user can give any kinds of input. Let's say whenever I have given, okay, whenever I have given how are you, okay, how are you, let's say this is the user input, how are you, okay, this is the user input. And how I created the chains, I think you remember how we created the chains. Let's say chain is equal to, first of all it will take the prompt, okay, prompt, then I given the pipe symbol, then I executed my chat model, okay, chat model. That means this is the prompt user has given. That means inside prompt, that means prompt is equal to would be how are you, okay, and this how are you will pass where? To the chat model. It will pass to the chat model, and chat model will give you the response, and this is what actually we are storing inside response. Okay, I think remember we're storing inside the response. Okay, response will have some of the response. That means it will have some metadata as well as your content. And if you just write like that, response dot content, okay, here you will get the Spanish, okay, Spanish sentence of the how are you, okay, Spanish sentence of the how are you. This is what actually it is happening. That means this is going to be my chain. Okay, this is my chain. That means after prompt is executing, then after that LLM model is executing. Now you can create like multiple chain here. You can give another pipe symbol, you can add another executable here. You can give another pipe here, you can also give another executable here. Okay, that's how you can create a complex chain also. Okay, multiple chain also, it is also possible. And this part I will be also discussing whenever I'll be discussing about this one, Langchain expression language. Okay, that means LEC, Langchain expression, LECL. Okay, Langchain expression language. So here actually I'll be discussing more about it. Okay, how to create the, let's say complex, very complex chain, how we can create multiple runnable and all, everything I'll try to discuss here. Even you can also check the documentation, chain in Langchain. So this is the older version of the Langchain. You can see this is the older documentation. So they are using this chains function. Okay, but I need the latest one. So here I can search simple chain action. I think I saw somewhere. So that's why I told you this documentation is still terrible. It's not actually organized. Okay, so if you're finding something, so it would be hard for you. So here you can see, guys. So they're using this pipe symbol. Okay. So retriever prompt model output parser. I'll tell you what is this retriever prompt output parser. So this is like more complex chains they have created with the help of multiple runnable. Okay. So whenever we'll be creating the RAG application, that time I'll tell you, okay, what is a retriever. Then so this is what we have created, prompt and model. Okay, prompt and model. I haven't showed you the output parser as well. Output parser I will also discuss. So that means I'm just giving the prompt directly and to my model, and model is giving the output, and this is what actually I'm storing in the chains. Okay, see. Okay, that's why I need to write this line. So result.content, then it will give me the content. But with the help of output parser, I can directly get the output. Okay, and with the help of output parser, you can also specify the format, what kinds of format you need as an output. Okay, this is also possible. So let me show you one example of the output parser. Now we'll be exploring about the output parser inside Langchain. Let's say you want to reformat the response of the large language model. That time you can use output parser, okay, inside Langchain. So with the help of output parser, you can reformat the text in any kinds of format, whether it's a JSON format, TXT format, okay, anything you can perform. So let's see the demo of the output parser, how it can be used inside Langchain. Okay, output parser. So again, let me initialize my chat model. So I'm going to initialize this OpenAI chat model. So GPT 3.5 Turbo 0125, this is the chat model. Then let me show you one example of the parsing output. So here I already created one example. Let me show you. So this is the example, guys. So you can see, first of all, I'm importing this prompt template. Okay, prompt template. And this prompt template I'm creating from template. That means inside that I'm passing one prompt. So return a JSON object with an answer key that answers the following questions. That means I'm telling my model I need a JSON object output. Okay, JSON object output of the following question. That means and to get the JSON format output, you have to import another function from the Langchain, output parser.json. So called simple JSON output parser. You can see I'm initializing this object. Then I'm creating the chain. So first of all, I'm giving the JSON prompt. That means this particular prompt. Then I'm giving the LLM, that means my large language model. So here what I can do, instead of chat model, maybe I can use this model. And first of all, I will show you the this model, my LLM model, that means my completion model. So I think you remember this prompt we have created for the completion model previously. So let me show you again. So for completion model, so you can see I'm using prompt template. Okay, and for chat model, I was using chat prompt template. Okay, this is the difference. So first of all, I'll show you the prompt template with the help of this one, completion model. So you can see I've created the chain, and this is the output parser. That means the output parser we have created, that means the output actually my model will give me, this would be a JSON output. Now let me show you. So if I execute the program, now I'll give the input to the model. So here is the input I'm giving. JSON chain dot invoke, and this is the question I'm giving. Okay, the question actually user will provide what is the biggest country. Now see, if I execute, the output should be a JSON. See, this is the JSON output I got. So this is the key and this is the value. Now if you want to check the type, you can also check the type. For this, you can store inside a variable and simply you can see the type. See, this is a dictionary. So dictionary is nothing but it's a JSON only at the end. Okay, you can directly convert this dictionary to the JSON, because you can see dictionary also having key value pair. Okay, JSON is also having key value pair. Okay, both are same. That means you can also specify the format, what kinds of format output you need from your large language model. Okay, so this is called actually output parser. Okay, with the help of output parser you can do it. Got it, guys? So previously I didn't use any kinds of output parser, that's why it was giving me this kinds of response. That means AI message. Okay, AI message object response. And if I want to get the content, I used to call the content. Okay, you can see I used to call the content. But now the output I'm getting, it is returning as a JSON. Okay, it is returning as a JSON because you have specified return a JSON object with an answer key that answers the following questions. And here you have specified the output parser, which is nothing but simple JSON output parser. Got it? So this is what actually you have to remember. And we can also customize it, okay, as per our requirement. Okay, we can also customize it as per our requirement. Let me show you another example. So this is like more advanced one. If you are creating something, let's say you need complete customization output, that time you can do it. So you can use something called pydentic, let's say function from the Langchain to do this. Okay, let me show you. If you want to create any custom output format. So first of all, let me import. These are the library. So I'm importing JSON output parser, and from prompt I'm importing prompt template, and Langchain core you can see I'm importing pydentic v1 base model and field. Okay, now you have to create a class. So this is the class. So I've created a class called joke. You can give any kinds of name as per your project requirement. I've given a joke. Now you have to inherit with the base model. Okay, base model, whatever model you have imported from the pydentic. And what is pydentic, guys? This is the Python concept. Okay, if you want to understand, you can simply search over the Google what is pydentic inside Python. You will try to understand. Okay, with that of pydentic, we can create a specific format. Okay, this is also possible. And for this, you have to inherit with the base class. Inside that, here I'm creating two variables called setup and punchline. And this variable type is string. Here I have said this should be a string type. Inside field, you have to give the description. So this is the description I have given: question to set up a joke. And inside punchline, I have given answer to resolve a joke. Okay, this is my class I have prepared. Now what I will do, this one I will pass to my LLM, but I have to pass as a JSON output parser. Now see, the JSON output parser I imported. Inside that, you have to give this pydentic object is equal to this class, the class actually you have created, the custom class, and prompt template. Okay, so this is my template, answered the question, that means format instruction. So what is format instruction? Let me show you. So let's say if I execute this one, if I execute this JSON parser, let's say JSON parser dot get format instruction. See, what is telling? It is telling a return a JSON object. So here you already given the prompt, return a JSON object. Okay, so if you call this method get format instruction, that means it will also return the same thing, return a JSON object. So this logic actually we are applying here. So you can see parser, the parser we have created, I'm calling get format instruction. That means it will tell you it should be the pydentic, okay, pydentic format. That means the custom class you have created, this particular format. Okay, so this is what actually it will accept. Sorry, here it will accept. Then input query, whatever query user will input, and the format instruction. So the get format instruction. So this logic actually, okay, that means you are telling it should be a custom, okay, custom format, the format you want to create. Now here I'm creating the chain. So first of all, I'm giving the prompt, then I'm giving the large language model, then I'm giving the parser, the custom parser I have created. Okay, then I'm doing the invoke operation, chain dot invoke query tell me a joke. Now see, if I execute the program, now see the format you have specified, it will give you the same format output. See, setup, I think you remember setup. Okay, so question to set up a joke. So this is the question to set up a joke. So why couldn't the bicycle find its way home? And here is the punchline, answer to the resolve the joke. Now you can see because it's lost its bearings. Got it, guys? And now whatever specified format you have given, okay, the same format is giving you the output. So this one is more advanced one apart from this one. Okay, this one. And no need to worry if you are getting it difficult. I will discuss this chain in detail. That time it would be more clear. Whenever we'll be starting with the Langchain expression language, that time it would be more clear. Okay. So if you go to the code, I think you will be able to understand. It's not very complex. Okay. Whatever things I have written. See, this one is the pre-built one. That means I'm simply calling the simple JSON output parser, and my model will give me the output as a JSON format. But if I want to create my custom output format, that time I can use the pydantic. Okay, I can create a class. Inside the class, I can specify how many variable I want. Okay, how many variable I want, and what would be the format, what would be the data type. You can specify everything. Then you need to use the same JSON output parser. Inside that, only you just need to mention the pydantic object is equal to your class, the class you have developed. Then you have to create the prompt template. Inside that, you will be giving this particular get format instruction. That means the parser, that means you are telling this class I want to use, this let's say format I want to use as an output. Okay, then whatever user will give that, it will go to the prompt. Then prompt will send to the large language model. Large language model will give to the parser, and parser will give you the output. And inside parser, you have already set it. Okay, your custom prompt template. So guys, now we'll be discussing about how we can work with our custom data, because so far actually we did the inference operation with our large language model. But let's say you have some custom documents, and how you can pass these custom documents to the large language model. Let's say you are having PDF document, TXT document, CSV documents, HTML documents, okay, any kinds of file format. So how we can load these other documents. Then I'll be also discussing about the basic RAG concept, because whenever we use our custom data, we have to follow some certain step. Okay, this is called actually RAG concept. So I'll give you the basics idea about the RAG concept. Then next we'll be also discussing about this RAG in detail. We'll be also implementing the RAG, okay, as a practical way. Then I think this part would be more clear. So let's see how we can work with our custom data. So if you have any custom data with any kinds of specific format, how we can load with the help of Langchain. So first of all, I'll be discussing about data loader. Okay, data loader. That means how to work with custom data. So it can be any kinds of format. It can be PDF format. It can be, let's say, HTML format. It can be, let's say, JSON format, Excel format, any kinds of data you can consider in that case, right? Now, the second thing I'll be discussing about what is RAG. That means introduction to RAG. And what is the full form of RAG? Retrieval. Okay, Retriever-Augmented generation. Okay, Retriever-Augmented generation. Then third, we'll be discussing about splitter. That means we'll be breaking down this RAG. Okay, so let me just write down. Yeah, so we'll be breaking down this RAG, and inside a RAG actually we'll see different kinds of component. The first component we'll be discussing about, which is nothing but splitter. Splitter. Okay. Then the second component we'll be discussing about embedding. Then we'll be discussing about vector store. Then we'll be discussing about retriever. Okay, retrievers. Then once we got the understanding of this, there is another topic we'll be understanding called top K. Okay, top K inside a retriever. Okay, what is top K inside retriever? I'll try to discuss. Next session will be learning one RAG demo. That means I'll show you one RAG application. Okay, RAG with Langchain. Okay, Langchain expression language. That means we'll be building one RAG system. We'll be using our custom data, and we'll be building the RAG system, and we'll be using this Langchain expression language there. Okay, our new Langchain syntax we'll be using. to implement the entire, let's say, RAG system. Okay, so this is the idea. Okay, fine. So now see, as of now, I think you remember, as of now, what we have done, we have only done the generation, okay, with the help of large language model. Let's say here we are having one LLM. So as of now, what we have done, we have given a prompt. Okay, we have sent a prompt and my model was giving me some response. Okay, response. And to give the response, actually, that actually information it is using. Okay, so it is using pre-trained knowledge. Pre-trained knowledge. That means during training these kinds of large language model, let's say if I'm talking about GPT 3.5, okay, GPT 3.5 Turbo. So whenever I'm talking about this model is already trained with some data set, right, over the internet. I think in 2000 till 2023, I think till October, they train they collected the data and they train these kinds of model. Okay, if I'm not wrong. So this model is having actually these are the information. Okay, this model is having, these are the information. Let's say whatever data they used to train the model, it is already having, these are the knowledge. So if I'm asking anything related to that, it will be able to give me the response. But what about you are having some specific data? Let's say if I ask, let's say, let me show you one example. What I can show, guys. So I'll open up my code. So here I'll create a notebook. Just a minute. 03. I'll name it as, let's say, data loader. RAG demo. IP1B. So here, what I can do, I will initialize my LLM first of all. I think you know how to initialize the LLM, yes or no? If I want to initialize the LLM, first of all, I have to load my secret keys. Okay, I have to load my secret keys from where? From the environment. Okay, it is telling plain text because I have to select my kernel. So here I'll be using OpenAI model. That's why I'm loading the OpenAI API key. But if you want to use any other model, let's say you want to use Grok API, you want to, let's say, load Llama model or Mistral model, that is free model, you can use Grok API in that case. Okay, so I already have the OpenAI account. That's why I'll be loading OpenAI model. You can also load the Grok model as free. I already showed you how we can, let's say, load different kinds of model. Now, first of all, let's load the OpenAI API key. After loading it, so first of all, let me load one chat completion model, because I already told you mostly we'll be using chat completion model, okay, instead of completion model. So you can see I'm importing one chat completion model, which is nothing but GPT 3.5 Turbo 0125 model. Okay, so this is the model I have loaded. Now, how to let's say give the prompt to the large language model. I think remember, let's say if I am using chat model, so that's how I have to give the prompt. So this is the way we can send the prompt. So what I can do, I'll copy this prompt as it is, and here I think just let me copy from previous example. So here is one example I'll copy, and here I'll try to paste it. Now here I can give URN, let's say URN helpful, okay, helpful assistant. Now here I can give one input. Let's say I'll tell me about DS with Bappy. Let's say I'll give my YouTube channel name. Let me see whether it is able to give me the answer or not. So I mean, whenever they train this model, I'm not sure actually they took my data or not. Okay, I mean, let's see. So what I can do, I can print the response here simply. Okay, so now let me execute. See, if I show you the content only, if I print it, So it is telling, I'm sorry, but I could not find any information on DS with Buppy. It seems like it may be a typo or terms that is not widely recognized. Could you please provide more context or clarify your question so that I can better to assist you? Because whenever they trained this model, that time, that time they were not using my data. Okay, that means my YouTube, information was not there inside the, let's say, data set, whatever data set they used to use. What I'm trying to say, let's say whenever I'm performing the inference operation with the pre-trained model, that trained model we are using, let's say direct model we are using, and if I'm asking any kinds of prompt, it's always not, let's say, possible you will be getting the response. Let's say if you are asking anything which is not available in the knowledge base, okay, in your model knowledge base, that time it won't be giving you the response. Okay, and here is the example I already showed you. If I'm asking related DS with Buppy, it is not able to give me the answer because it hasn't trained with this particular data. So in that case, what I can do? In that case, what I can do? Can I use my custom data? Can I use my custom data and can I give the information to my model? Is it possible? Yes, it is possible. For this, we have to first of all learn how to load the data, how to load different kinds of data. Let's say here I'm having one data folder. You can see inside data folder, I'm having different kinds of TXT file. Sorry, different kinds of file. Let's say I'm having PDF file, I'm having HTML file, I'm having TXT file, then I'm having CSV file, I'm also having database file. Okay, so these are the different kinds of file I'm having. Now, if I want to load these at the data, and if I want to pass the information to my large language model, how it can be done with the help of Langchain, because I already told you Langchain is a universal framework. It can support everything. That means you can connect all kinds of data sources. You can connect all kinds of technology. Okay, you can connect all kinds of platform. Okay, and it can also load different kinds of large language model with the help of only one framework. Okay, that is what I already given you the intuition in my first session. Okay, so now we'll see how we can load these are the data. Okay, so this is called actually data loader inside Langchain. First of all, we have to learn how we can load different kinds of data, different kinds of format of the data. Then we'll be using that particular knowledge to create our RAG based application. And I'll tell you what is RAG. No need to worry as of now. If you're not familiar with RAG, I'll also give you the intuition about the RAG. Okay, so yeah, so first of all, let's try to see how we can load, let's say, PDF data, HTML data, TXT data. Okay, so these are the data, how we can load it. So this is our main objective. So for this, here I'm going to write a comment. So here I can write data loader. Okay, data loader. Okay, so the first data will be loading, which is nothing but TXT data. That means if you are having any TXT file, how we can load it. So here, so let me just write down here TXT data loading. So for this, you have to import one function from the Langchain community. So all kinds of data loader are available inside Langchain community, guys. Okay, so first of all, write like that, Langchain community. So I already installed Langchain community, I think, remember. So Langchain community is not there. Let me just find. Yeah, so Langchain community is not there, so I can install the Langchain community. So here is the Langchain community. Okay, Langchain -community, and this is the specific version I'm installing. Okay, and try to remember all kinds of data loader functionality are available inside Langchain community, because I already told you it is using core Langchain only, but Langchain has divided. Okay, these are the framework in a different let's say functionality. Let's say if you want to load the model, OpenAI model, you have to install Langchain OpenAI. Let's say if you want to use Grok API, you have to install Langchain Grok. If you want to, let's say, load the data, you have to install Langchain community. Okay, that's how actually it is having different kinds of sector, different kinds of sub framework. Okay, so this is what you have to remember. So for me, I already installed in my environment, but for you, what you have to do, guys, you have to execute this command. So this command pip install -r requirement.txt. So it will install this particular Langchain community in your let's say environment. So for me, I already have it. So what I'll do, I'll just try to close it. Then here I'll just try to import. So from Langchain community dot documents loader. Okay, documents loader import. So text loader. Okay, so because this is a TXT file now, so here you are having one function called text loader. That's it. Now you have to specify the location of the text. So inside this particular function, you have to give the location, like which TXT file you want to load. Let's say I want to load this TXT file. Let's say this one, be good TXT file. I'll just try to copy the path, and here I can mention it. Now see, it is copying the entire path, but I don't need the entire path. I only need the relevant path because I'm inside my project working directory. So what I can do, I can again copy it. So right click and try to copy the relevant path. Okay, relative path. So here I can paste it. I can see it is using backward slash. In Windows by default it will use backward slash, but what you have to do, you have to use the forward slash. Okay, forward slash. That's it. Now after loading the data, it will give you the data loader object. So let me create an object here. So I'll store inside a variable. Then after that, you just need to call the load function. So let me just write loader dot load. Okay, now it will give you the data. So what I can do, I can just store inside a variable called loaded underscore data. Okay, now see, if I execute the program, you will see that this txt, whatever txt you are having inside this file, this data has been loaded. Okay, now let me show you. So if I print this data load, right, loaded data, you can see this data has been loaded and it has loaded as a document. You can see it has loaded as a document. The type is document. Okay, always try to remember, guys, if you are using Langchain, llamaindex, whatever orchestration framework, whenever you are loading the data, it will load as a document, because inside generative AI, we call the data, we call all the custom data as a document. Always try to remember. Okay, we call it as a document. Okay, so this is the document, guys. So first of all, it will show you the meta sources. That means from which file it has loaded the data. You can see it has loaded the data inside data folder. This is the file bgood.txt, and this is the page content. That means whatever content you are having inside that. So here is the content it has loaded. Okay, it has loaded. So this format you have to give to the large language model, otherwise it won't be working. So make sure your data is a format of document. Got it? If you're loading any kinds of custom data, always you need to remember. Yeah, so this is for actually txt data loader. Now what about CSV? Let's say I'm having a CSV file. How to load the CSV file? So for this, let me show you the syntax. So here I can write CSV loader. Okay, now let me show you the different kinds of data your Langchain supports. So data loader, you can see txt loader. So this example I have already given you. List of the built-in data loaders. Yeah, now you can see your Langchain supports all kinds of platform. You can see you can load the data from AC ROM, then byte loader. Then you can also use different kinds of loader. You can also use AstraDB, archive. I think inside archive actually we are having all kinds of research paper nowadays. Then Azure Data AI. Then see different kinds of Cassandra. Then you can also load Discord data. Okay, Dropbox data. All kinds of social media platform also you can connect. You can also use Figma. See different kinds of data loader are available inside Langchain. It's not only about TXT data loader, PDF data loader, JSON data loader. It's not like that. It's all about all kinds of framework, all kinds of third-party, let's say, platform. You can also connect with the Langchain. It is also possible. See, guys, PySpark, Slack, Telegram. Okay. Then if you are having any custom URL, any website, you can also load the data. XML, YouTube transcript, Wikipedia. Okay, Twitter, all kinds of data you can load it. All kinds of data you can load it. Now simply, let's say you want to learn how to load the CSV data. In that case, what you can do, just click on the CSV. In the documentation, you can see. Okay, they have all the tutorial. Okay, it's not like that always this documentation would be hard for understand. Sometimes you will see some of the functionality would be easy to understand. Let's say if I'm talking about data loader, if you click on the CSV, you can see how to load the CSV data loader. First of all, you have to import this particular statement, CSV data loader, from the Langchain community. After that, you have to give the CSV path and it will load the data as it is. Okay, so that's how, see, they have also given the code snippet. So try to open it up and try to copy the code and try to paste in your notebook. Okay, you will be automatically getting the understanding. So for me, what I will do, I'll show you some of the data loader, but for you, you can explore all the data loader. Let's say you need to load the Slack data, or let's say you need to load the data from the Telegram. So try to go to the documentation, try to open it up, and whatever code they are suggesting, try to copy paste and try to load the data, try to connect with the Telegram. Okay, but I will show you most actually frequent format. Okay, most frequent format, whatever let's say format people are using in their day-to-day life. Okay, so some of the example I'll show here. We have seen how to load the TXT data. Now let me show you the CSV data, how to load the CSV data. So this is the example of the CSV data. First of all, you have to load this particular function from the Langchain community document loader. And this is my CSV data, guys. You can see straight tree list CSV. So this is the comma separated data I'm having. Now if you want to load this particular CSV, I have to use CSV loader and again try to call loader.load. Okay, now if I show you the loaded data, Okay, so this is the entire CSV data you'll be getting. See, okay, this is the entire CSV data you'll be getting, and all the row it is considering as a document. You can see all the row it is considering as a document. Row 0, row 1, row 2, and so on. Okay. Now let me comment it. Now what about HTML? Let's see if you're having any HTML data. So here I'm having one HTML. Let me try to open it up. So start up HTML. See, this is the HTML page I'm having. And let's say I want to load these are the data, so how it can be performed. Okay, with the help of Langchain, we can easily perform it. Let me show you one example. So here is the example, guys. Okay, so you have to use this unstructured HTML loader, this particular function from the Langchain community. Inside that, you have to give the HTML path. So this is the HTML part. Inside data, I'm having this particular HTML. And make sure whenever you are doing it, okay, whenever you are doing it, you have to install one library called bs4. So inside requirement.txt, I can mention it. bs4 as well as the unstructured. So these two packages you have to install, because you will be loading the unstructured data. Inside HTML, you will see unstructured data for this, and it is beautiful soup as well as the unstructured. Okay, these two packages. So those who have performed web scraping, I think you know what is beautiful soup and what is unstructured. Okay, so similar kinds of things Langchain will also apply. It will perform the web scraping and it will extract all the information from the website itself, from the HTML page itself. So this is the idea. So let me save, and after like adding inside requirement, make sure you are running this command, guys. So requirement.txt. So it will install all the package in your systems. For me, I already have installed all the package. That's why I'm not going to install again. That's it. Now let me load the HTML content. So you can simply execute. So it will load the HTML content. So inside this HTML page, we are having so many content. That's why it is taking time, because it is extracting all the information one by one. Okay. So it will take some time, guys. What I'll do, I'll stop the execution. But for you, we can execute and you can see whatever content it will extract. So as of now, let me clear the output. Okay. Now the next thing, I'll show you how we can work with the PDF data. So PDF data. So you can see I'm having the PDF documents. Okay. So how to load the PDF document? So this is the snippet to load the PDF document. You have to use PyPDF loader. See, all the import are same. Only you just need to change with respect to your data format. Let's say you need to load the CSV at the time CSV loader. You need to load the HTML at the time HTML loader. PDF loader. Okay, that's how you have to only change the function. Inside that, you have to specify the PDF. So this is the PDF I want to load, and you have to load this particular PDF. Okay, so loader.load and split. Okay, you can call this particular function. Now if I show you the loaded content, but before that you have to install another library called PyPDF. So inside requirement, I'll try to add PyPDF. Okay, with the PyPDF, it will extract the information from the PDF document itself. Okay, this is what you have to remember always. Okay, so now let me save and let me execute here. Now you'll see that these are the content I had inside my PDF. So it is having actually 4 pages. If you open the PDF, so this PDF actually 5 pages PDF. So this is the PDF, guys. You can see it is having 1, 2, 3, 4. Okay, 4 pages. So that's why it is telling 4 pages PDF. So you can see it is having 4 pages. Okay, 4 pages, 4 sources, and all the content it has extracted one by one. Okay, now if you want to see the page content, so simply you can see this is a list. Okay, I want to take the first item. I'll give the first ID, and I only want to see the page content of it. Now see, it will show you the content, whatever content it has extracted. That's it. Okay, now let me show you how we can load the data from the Wikipedia. Wikipedia data loader. Okay, for this you have to install one package called Wikipedia. Okay, Wikipedia package you have to install. Then after that, this is the syntax. Okay, this is the syntax. See, now here inside query, actually what you can do, you can give any kinds of any kinds of let's say topic name. So what I can do, let's say here I can mention like that. Let's say query I want to ask about, I want to, let's say, get the information about, let's say, Tesla. So I'll give the Tesla here in the query. And what I'm telling, I need load maximum documents 1. That means it should only return me 1 documents. You can also increase the number. If you need some more information, you can increase the number. You can give 2, 3, okay, as per your requirement. Now, if I see execute the program, it will give me the content related Tesla. Okay, see. So it is giving me the content related Tesla. Okay. Now there is another thing you can perform. So you can directly, whatever information you are getting, you can directly pass to the large language model and you can perform the question answer on top of it. Okay. That means you can give as a, let's say, context. Okay. Context to your large language model. So how it can be performed, guys? So let me show you another example. So here I'll again create this Wikipedia data loader. Now see, inside query and this load max, you don't need to pass anything. Just write query is equal to name and keep it as default. No need to change anything. And simply execute this line of code. Okay, see here, I'm importing prompt template from the prompts. Then chat promptlet from message. I think I already explained, okay, what is prompt template, how to create the prompt template and all. I already clarified. And here is the human prompt I'm giving. Answer this question. Here is the extra context. And from where I'll get the context? I will get the context from where? I'll get the context from the Wikipedia. Okay, I'll get the context from Wikipedia. Let's say whatever user will ask. Okay, whatever user will ask. So this, let's say, query, first of all, will go to the Wikipedia. Wikipedia will return me the documents. And these documents, I will give the context to my large language model. Okay, and this will give me the answer. Okay, so it's still running. So let me stop the execution and again re-execute again. Okay, so what I can do, I can delete this part. It's not required. So let's say whatever Tesla information I got now, so I can pass as a context. That would be fine. So here I'll give, let's say, Tesla. Tell me about about Tesla. Okay, tell me about Tesla. Now see, whatever answer I'm getting from my Wikipedia, I'm giving as a context. You can see loaded data. The loaded data I'm giving as a context. That means what is happening, just try to see. Let's say this is my large language model, LLM. Okay, LLM. So here I'm asking what is Tesla. This is the prompt I'm giving, right? What is Tesla? And here I'm also giving the information about Tesla. And from where I'm getting from the Wikipedia. Wikipedia is giving me information related Tesla. Okay. This information I'm passing to my large language model as a context. Okay. As a context, actually, I'm passing. Then whenever you are asking what is Tesla, so what will happen? It will refer this particular context. This context it will refer. Okay. This context it will refer and it will give you the response. Okay. It will give you the response. So let me show you the execution. So if I now execute the program, so now let me do the invoke operation. So chat model invoke, I'm giving the message. Okay. Now let me show you the content. See, this is the response I got from the large language model. Okay. Now see here what you are doing, you are giving the complete actually data, complete data to the large language model as a context. Now just try to think if your, let's say Wikipedia, okay, Wikipedia, let's say return, Wikipedia return, let's say 10,000 tokens, 10,000 tokens response. That means 10,000 tokens information. Let's say whenever you given the Tesla in the Wikipedia, let's say Wikipedia return 10,000 tokens, 10,000 tokens, let's information. And you are using GPT 3.5 turbo model. GPT 3.5 turbo model. Now, if I go to the model documentation, let's say OpenAI model, sorry, not pricing, model list. Model OpenAI platform. Let me open it up. Now, if I go to the GPT series, GPT 3.5, GPT 3.5, just let me find out. Yeah, 3.5 turbo. If I'm talking about this model, now see what is the context window, guys. Maximum output tokens. Oh, okay, they have increased the context window. Let's say I'll increase it here. Let's say instead of 10,000, I'll just write 30,000. Okay, 30,000. Let's say 30,000 tokens you are having. Now you can see the model GPT 3.5 turbo takes context window, that is input token. It can take 16,385 16,385 tokens it can take as an input. Okay, this model can take, so let me just write here GPT 3.5 turbo. This model can take 16,385 85 tokens as an input. Okay, and it can give the output 4,096 token. 4,096 token it can give you the output. Okay, so this is the limit of this large language model. Now let's say the context, context you got from the Wikipedia, it is, let's say, 30,000 token. In that case, if I give this data to my large language model as a context, so will it able to take it as an input? Because you can see the input token limit is 16,385, but you are trying to give 30,000 token. Possible? No, definitely it will give you the input error limit, right? Input error actually it will give you. And whenever you are giving 30,000 tokens to your large language model, that means how your model will charge. If you go to the model pricing, so if I show you OpenAI model pricing, it will charge you based on the token. Okay, token limit actually. Let's say if I am talking about the GPT 3.5 turbo model. So what is the turbo model, guys? Here is the turbo model, GPT 3.5 turbo. Okay, turbo model. Let's say I'm talking about this model. Now see, 1 million token. Okay, 1 million token input. It will charge you $0.50. Okay, and if it is giving you output is equal to 1 million token, it will charge you $1.50. Okay, now just try to think about. Okay, the tokens actually you are giving to the model, that means the input you are giving, if your token size is high, that means it is like huge, that time your charge will also increase, yes or no? Because it will charge you based on the token. If it is taking like big token, if it is giving, let's say, big token output, definitely you will have higher cost that time. Okay, and you can't pass actually 30,000 input to the GPT 3.5 turbo because the input limit is 16,385. Okay, so this is the idea. That's why there is a drawback. This is the drawback actually. We can't directly load our custom data. We can pass to the large language model. It is not possible. Okay, because of that issue, because of the input issue. So what I can tell, guys, you can see the drawbacks. The first drawback I saw, input issue, input limit issue. Okay, then the second drawback you saw, which is nothing but cost, higher cost. Yes or no? Okay, so how to overcome this issue? How we can overcome this issue? Is there any way we can overcome this issue? I want to use, huge document. Let's say inside this txt file, let's say I'm having very huge amount of data, let's say I'm using one books. Okay, I'm using one books. So inside the books, actually you'll see there would be 1,000 pages, there would be 2,000 pages. And if you, let's say, extract all the data, if you extract all the data and if you, let's say, count the token, how to count the token? So for this, what you can do, you can simply copy some text and there is a token counter website is there. So OpenAI token calculator, token counter. I think this one, just let me open it up. See here, I can paste the text. Now see, inside this text, actually you are having 98 token and 414 character. Okay. Now there is also price calculator is also there. So based on the token, how much it will charge you. So here I think token price calculator, OpenAI. So here you can see set width and height. So this is for the image. Okay, this is the image model, multi-model. But if I'm talking about text model only, for text model also, I think they have also created the calculator. I'm not sure, but for image model it is available. So you can set the image height and image width. Based on that, you can see the like price. Okay, how much it will charge you. But I'm not sure about the text calculator. OpenAI API pricing calculator. Yeah, input token. Input token, let's say you are having 1000 token as an input and 1000 token as an output. Number of API call, let's say you have given 100 times. So based on that, see, this is the pricing. So if you're using GPT 4.0 model, so this is the price. Okay, this is the price. So that's how you can see different websites are there nowadays. They will show you the calculator, let's say, I mean, how much it will charge you and all. And no need to worry, in future I will also show you how we can track the let's say cost and all. Okay, this thing we can also develop inside our application. So that is the issue actually. That is the drawback. That means there is the input limit and there is the cost issue. Okay, input limit and cost issue. So for this, researcher had actually has developed one technique called RAG. Okay, RAG. That means retriever augmented generation. Okay, this technique. Okay, retriever augmented generation. Now inside RAG, what is happening? Okay, what is the idea inside RAG? So that is what I will try to explain. I already created one notebook. Let me take a screenshot of the content and here just let me paste it. Okay, see, this is what actually your RAG. So intro to RAG, you can see load large dataset asset and ask the LLM question about it. That means with the help of RAG. Okay, with the help of RAG, what we can do, we can load large dataset. Okay, large amount of dataset. Okay, large amount of dataset we can load and we can perform the question operation with the help of large language model. Okay, now what if the loaded data is too large? If it is too large, okay, if it is like huge, then that time what we can perform, we'll be using something called RAG technique. See, always try to remember, if your loaded data, that means the data you are loading, let's say you are having a txt file, the data you have loaded. Okay, if it is less than your model, okay, model input limit, okay, that time you can directly pass this data as a context to the large language model. There is no issue. Okay, but if it is like greater than the model input, let's say in this case actually my model input is, if I show you that model, so here I think I already written, yeah, 16,385. Let's say after extracting the data, you saw the token is like more than this size. That time what you can do, we can't directly give the data to the large language model. It is not possible. For this you have to use the RAG technique. Now inside RAG technique you are having some step. Okay, I can see when you load a documents, you end up with a strings. That means string kinds of data you are having inside that particular, let's say file. Sometimes the strings will be too large to fit into the context window. That means your input size may be too large, okay, to fit into the model. That means we saw the context window. That means the input limit of the model. Okay, in those occasions, oscillations, we'll be using RAG technique. Now inside RAG technique, the first thing you have to perform, you have to split the documents into smaller chunks. So the first thing, guys, you have to remember inside RAG, you have to split the documents into a smaller chunks. Okay, I'll tell you what is chunks. As of now, just try to remember. The first step you have to perform, you have to split the document into smaller chunks. The second step you have to perform, transform text chunks into the numerical chunks. That means you will be having the textual number, text data. And we know that we can't directly pass the text data to the model, any kinds of AI model. It's not possible we can directly pass the text data. So what I have to do, we have to convert this text data to the numerical representation. That means to the vector representation, yes or no? Maybe you have already worked with machine learning, deep learning. I think you know. If you're using any image, if I'm using any text, first of all, I have to do the encoding. I have to generate the embeddings. That means the vector, that particular vector will be passing to the model. Okay, so this is what actually we'll be performing. That means we'll be transforming the text data to the numerical representation. And for this, we'll be using embedding model. Okay, there are different kinds of embedding model are available. We'll be using embedding model for this. Okay, now loaded embeddings to a vector database. That means we have to store this at the embedding to a vector database. If I want to perform the QA operation, if I want to perform the chat operation on top of my custom data, the first thing I have to load my data to the vector database, because vector database is like very powerful database. Okay, very powerful and fast like database. You can't use any kinds of traditional database here. Okay, traditional database doesn't support any kinds of vector store operation. So you have to always use vector database, and there are some vector databases are available. I think you know Pinecone is there, WebAT is there, ChromaDB is there, Fice is there. Okay, then Postgres SQL is there. Now we'll be loading the question and retrieve the most relevant embeddings to the responded. That means after storing to the vector database, we'll be creating the retriever. Okay, and what is retriever? Retriever means it will retrieve the similar kinds of response. Let's say you have asked one question, what is Tesla? So the information you have given to the model, it is also related to Tesla information. Now it will retrieve the information related to Tesla, like what is Tesla? So what are the similarity, let's say results it will get, it will try to extract, it will try to retrieve. Okay, this is called retriever. Then send the embeddings to the LLM to format the response properly. That means we'll be sending that question as well as the retrieved output to the large language model, and large language model will process and it will give me the answer. Okay, so these are the steps you have to remember if you are performing the RAG system. Now we'll be breaking down each and every component. I will try to understand like what is chunks and how to, let's say, do the splitting operation, how to like generate the embeddings with the help of embedding model, how to create the vector store, how to create the retriever. Okay, and at the end I'll also show you how we can create the complete RAG application. Okay, so these are the part we'll be discussing one by one. I hope, guys, is it clear? So how we can overcome this issue if you are having huge amount of data, and if you want to give this data as a context to the large language model, in that case what we'll be doing, we'll be using RAG technique. So inside RAG technique there are 5 steps we have to perform. We split document into chunks, transform the text chunks into numerical representation, load the embeddings to the vector database, create the retriever, and we'll be sending the retrieved output as well as the query to the large language model, and large language model will give me the response. Okay, this is the entire idea. So this is what we'll be learning, and we can use any kinds of custom data. Let's say the first question I have asked you, remember, so tell me about DS with Bapi, and your model was not able to give me the answer about DS with Bapi, right? Now what we can do, I can create another txt file here. So let's say I'll give DS with Bapi data. Okay, data.txt. Now inside that I can keep some of the information about my YouTube channel. So what I can do, I can, let's say, open up my YouTube channel. I will go to the about section and I'll copy, and this information you can keep inside the txt file so that I can pass this information to my large language model. Okay, just let me reformat it. Okay, so this is the information about my channel. So whenever I'll create the RAG application, that time I'll tell you. Okay, now after creating the RAG, your model will be able to give me the response related DS with Bapi as well. Okay, that means I can use any kinds of custom document right now. It is possible. But before that, we'll be learning some steps. So these are the steps we'll be learning. How to perform the chunking, how to let's say convert our text to the numerical representation, how to store to the vector database, and how we can create the retriever. Then at the end, we'll be running the RAG technique. Okay, so this part will be covering in the next session. Next session, we'll try to wrap up everything. So guys, now we'll be discussing about different RAG component. I think you remember I was talking about RAG is having some component like splitter, embedding, vector store, retriever, and top K and so on, right? So now let's try to see all of the component in a practical way, like how we can develop them one by one. Okay. Then after that, we'll be also implementing one basic RAG application. Whenever I'm talking about RAG, actually, we'll be performing these are the steps inside RAG. That means these are the component you are having inside RAG. So first thing, we'll be splitting the data into smaller chunks. Then we'll be transform text chunks into numerical representation with the help of embedding model. Then we'll be loading this embedding model to a vector database. Okay. Then we'll be loading the question. We'll be actually creating the retriever. Then with the help of this retriever, we'll be passing the retrieved answer to the large language model as well as the question. Then my large language model will be able to give me the response, okay, with respect to that. So these are the actually component we'll be trying to understand. Okay, so first of all, let's try to discuss about this one is splitting. So here I have already written. So first of all, we'll be discussing about is splitting. Okay, this one. So what is splitting and why we should perform the splitting operation and why it is required. So first of all, we'll be discussing about splitting. Splitting. Splitting or splitter. See, what is a splitter? It's nothing but divide a large data asset in small parts. Okay, so this is called actually splitting. Now let me show you one example what I'm trying to say. So I already have one example, just let me show you. So this is the example, guys. You can see let's say you are having one let's say a large amount of data. Let's say you are having one original text. Let's say you have loaded this data from the txt file, pdf file, okay, JSON file, or any kinds of file. You have loaded the data, and let's say this is my entire corpus. Okay, this is my entire corpus. Now what I told you, I can't directly pass this data to my large language model. It's not possible because large language model is having some input limit. Okay, that means context window, fixed context window. Okay, so what we can perform is splitting. What is splitting? Splitting means you will be actually dividing the large amount of data in a smaller part. So let's say this is my entire data, and now after splitting, you will see that you will be getting different chunks. So this is your first chunks, this is the second chunks, this is the third chunks, and this is the fourth chunks. Now how it is creating the chunks? So there are some technique we'll be following to perform this splitting operation. So we'll be using something called recursive character text splitter. Then we'll be using something called character text splitter. Okay, these two methods will be applying. Then we can divide this larger amount of data in a smaller part. Now you can see inside the text actually you will be having new line. Okay, new line. So why am I talking about new line? Let me show you one example. So let me open up my previous example. So inside data, so if I open this particular file, let's say bgood.txt, now you can see after this line there is an empty space. Okay, there is an empty space. That means how, see, whenever I'm talking about actually programming language, how program will get to know after this sentence there is a space. Okay, after this sentence there is a space. That means it is starting from here, because by default here it will consider as a /n. /n means new line. Okay, new line. That means after this sentence there is no text. That means you have to go to the new line. Okay, so if you load any kinds of data with the help of Python programming or any other programming, you will see these kinds of actually symbol. Okay, /n/t. So these are the symbol actually you'll be seeing. So whenever you are having the /n, that means it's a new line. That means one sentence is completed and it is talking about the next sentence. Now if you see here this example, so here this is the sentence we are having. Now here we are having a /n. /n means this is a new line. It is writing in the new line. Okay, new line it is writing. So whenever I perform the splitting operation, that means this is considering my first chunks. Okay, now again it is splitting with respect to the /n. With respect to a /n, it is splitting. Now this sentence is considering as my second chunks. Okay, now again we are having the /n. Again it will split with respect to that. Then we'll be getting the third chunks. Then there is another /n. It will split. Then we will be getting the chunks 4. So that's how actually we can get the chunks. So that means we are having a bigger data, that means huge amount of data. We'll be applying the splitting operation, and split will split the data with respect to the slash n, and here we'll be getting different kinds of chunks. Okay, so this is the idea of chunking. Now you can ask me how we can perform the chunking. Inside Langchain, actually we are having two kinds of method. So the first method, you'll be using something called character text splitter. Okay, character text splitter. I will tell you how character text splitter will work. Then there is another one called recursive character. I think it's a recursive text splitter or character text splitter. Just a minute. Yeah, recursive character splitter. Okay, so these two methods actually we'll be learning. Now, first of all, let me show you how we can use the character text splitter. So I'll open up my code, and here I'm going to create a file 04. I will name it as, let's say, rag components. Okay, so here I'll select the kernel. I'll select this kernel. Fine. Then after that, first of all, I'll be loading the env file, because I will be using the OpenAI model. In case you can use any other model, you can use Grok model or any model, you can use, it's up to you. So let me load this OpenAI API key. All right. Then the next thing, we'll be loading that data. So inside data, we are having different kinds of data. We are having HTML, PDF, TXT. So let's load one TXT data. So here I'll be loading this data, actually begood.txt. So you can see this data actually I'll be loading, and you can see this data is a little bit bigger data. You can see we're having huge amount of text inside this file. Now I can't directly pass this data to my large language model. For this, first of all, I have to perform the splitting operation. That means we'll be dividing the this bigger text to smaller chunks. Okay, this is the idea. Now, first of all, let me load the data. So this syntax will load the data. I think you remember. Now this is the entire loaded data. Okay, entire loaded data. Now, if you want to see the page content, simply you can call the page content. You'll see the content of the data. Now, if I want to use character text splitter, this is the syntax, guys. Okay, you can see. First of all, you have to import a character text splitter from the Langchain _text.splitter. Okay, so from here you have to import this particular character text splitter. After that, you have to initialize one object of the character text splitter, and it will take some of the parameter. So the first parameter, it will take separator. Okay, separator. Now you can ask me what is separator. So here I have given one example. So I already told you, whenever you are loading any kinds of data. So if I show you with the help of Langchain, I loaded the data. Now you can see this slash n is visible. Yes or no, guys? So if I show you the data, this slash n is visible. See, okay, slash n is visible. That means slash n means it is referring the new line. That means after this line, okay, another line will start. Okay, which is nothing but this one. So that's why we are having this kinds of separator. So what I'm telling, so wherever you are getting this double slash n, that means if you see here, we are having the double slash n. See, double slash n. Okay, double slash n. So wherever you are having the double slash, so you can see double slash we are having also here. Then if you find here, you are having most of the double slash. Okay, double slash. So wherever you are getting the double slash, try to separate the data with respect to that. And chunk size I'm giving 1000. That means what will happen? So let's say here you are, this is the entire corpus. So let me clear. Let's say this is the entire corpus. So whenever it is creating the first chunks, okay, so let's say it will create from here. Then here, what is the parameter I have given? I have given chunk size is equal to 1000. That means it will count 1000 token. So let's say this is first token, second token, third token, fourth token, fifth token. That's how it will count. How many, guys? 1000. Let's say in this sentence we are having 1000 tokens. That means it will consider as my first chunk, chunk 1. Okay, chunk 1. So first of all, it will count 1000 token, whether it is having or not in this particular chunk. Then it will try to split that particular sentence. Okay, otherwise it won't be splitting. Okay, so this is the parameter you have to assign. Now you can ask me how to define this chunk size based on the model context input. Let's say if your model is taking 4096 token as an input, that time you can keep 1000 chunk size. Okay, so I've seen most of the people, they are using 1000 chunk size, and chunks overlap they're using 200. Okay, now you can ask me what is chunks overlap. Chunks overlap means you are overlapping the chunks. That means whenever you are creating the second chunks, second chunks again, it will start from here. Yes or no? It will start from here. But what you have given chunk overlap is equal to 200. That means it will go back 200 tokens. That means it will go back 200 tokens. Let's say 1, 2, 3, 4, 5. That's how it will go back 200 tokens. Let's say 200 tokens ends here. Then it will start the chunks from here. Then again it will count 1000. 1, 2, 3, 4, 5, 6, 7, 8. Let's say 1000 ends here. Okay, ends here. So this is going to be your chunk 2. Okay, so this is called chunk overlap. Now you can see there is an overlap. Okay, there is overlap you got. And with this overlap, your model will try to understand after this sentence is coming, because there is an overlap. There is a common token is coming. Okay, that's how your model will automatically get to know after this particular sentence, this particular chunks is coming. Okay, after this chunks is coming. That's how you have to perform for all that, let's say, data you are having. Okay, unless and until this chunks is getting over. So you'll be keep on applying this particular chunking, and you don't need to manually perform. So Langchain will automatically take care. So with the help of this character text splitter, will be automatically performing this thing. But I showed you, okay, what will be happening internally. So whatever code they have written internally, they are doing like that. That means they're looking for this kinds of double slash. They're separating the data. They're counting the chunk size first of all. If chunk size is missing, then they're also checking the chunks overlap, like how many chunks overlap you have to take care. So based on that, you will be taking the chunks overlap. Then what you will be doing, you will be creating the next chunks. That's how you have to complete for all the data you are having. And after that, you will be getting your chunk, like how many chunk you will be getting. Okay, after splitting your entire corpus. So this is the idea about chunk overlap as well as the chunk size. Got it? And length function, because it should count like how many tokens it is having. Okay, and how it will count with the help of length function. Okay, is separator regex is equal to false, so you don't need to give it true. Just try to keep it as false. Let's say you want to use any regular expression and all that. That regular expression you can also use. Okay, so this is like very powerful function they have created. You can send so many parameter. So if you go to the documentation of character text splitter, you will see there are so many let's say parameter it can take. But we are not going to use all the parameter. Just keep it everything as default. Only you just need to change this chunk size and chunks overlap. Okay, these two you have to change. Let's say you don't need chunk size 1000, you want to increase. In case you can increase, and if you want to decrease, in case you can decrease. Okay, that's how you have to change the parameter. That's it. Okay, so now let me execute and let me show you the output. So now this is the final code. So you have to call this object text splitter. Then there is a function called create documents. Inside that you have to pass your documents. So the documents actually we got. Okay, so we are giving the paste content only. Okay, the text only. You can see inside that I'm passing the text. Now see if I execute, so it will have all the chunk right now. See, so how many chunks it has created? If you want to see that, just pass it to the length function. So it has created 2 chunks. You can see first document and second document. All right. Now if you open this txt file, this bgood txt file, now you can see the first here. So if you count, okay, if you count all that token, that empty token also, you will see that it is getting 1000. Okay, 1000 token, because this empty space would be also counted. Okay, that's why you can see in the first chunks it is getting this one bgood, and the second chunks it is getting this one. Okay, this is the idea. Now you can take any big document and you can try. You will see that it will create so many chunks. So later on, whenever we'll be creating the RAG based application, that time we'll be loading the bigger documents. Okay, that time I'll show you. It will create so many chunks for you. Okay, now if you want to see them, simply you can give the ID. Let's say I want to see the first chunks. This is the first chunks. If you want to see the second chunks, you can also see the second chunks. Okay, this is called actually character text splitter. Character text splitter. Now the second splitting we'll be learning called recursive character text splitter. Okay, this one. And for this, you have to import it from the Langchain. So this is the syntax: Langchain text splitter, recursive character text splitter. And this is the syntax. Okay, recursive character text splitter. Now you can ask me how recursive will work. So let me first of all give you one text and let me show you how it will work. So what I'll do, I'll just try to pass the text. So here is the chunks I got. Now see how it is working. So let me open up my Blackboard. See, whenever I'm talking about recursive character text splitter, so it will actually perform the splitting with recursively. Okay, what is recursive? I think you know. Recursive means repetitively. That means first of all it will split the documents with respect to double slash. Okay, double slash. Sorry, double slash n. Okay, double slash n. You can see double slash n. Okay, so once double slash n is completed, then it will actually split with respect to the single slash n. That means in some times actually we'll see in the text you will be having single slash n as well. Let me show you. So here, see, there you will get double slash, then you will be also getting single slash. See, single slash. That means two kinds of slash n you will be getting. One is the double slash. Double slash means two new line, and single slash means one new line. So first of all, it will split the documents with respect to double slash n. Then it will again it will apply another loop. Okay, so let's say in the first loop, it will first of all split with respect to the double slash n. Okay, then inside that they will be performing another loop. Let's say second loop. Then it will split the document with respect to the single slash n. Okay, then it will perform the splitting operation. So this is what actually recursive character text splitter. That's why they are calling it recursive. That means they are performing recursively. Okay, this is the idea. So both technique you can use. Okay, with the help of both technique you can split your data. Either you can use character, either you can use recursive. Okay, both will work fine in that case. Okay, so we have learned the first technique, which is nothing but our splitting. Okay, splitting. Now what is the second technique? Second technique is nothing but I have to know how to do the embeddings, like how to generate the embeddings. Okay, so let's try to see how we can generate the embedding. So for embedding, we'll be again opening this file. And I can comment it. So what is embedding? Here I can comment. So embedding is nothing but here transform the small parts of the text into the number, that means vector, that are easily stored to the vector store and searched by the vector database. Okay, so how we can like generate the embeddings? For this, what we'll be using, guys, we'll be using embedding model. Embedding is also a large language model. Okay, it's a large language model. With the help of that, you will be generating the vector embedding. Show the embedding model. Okay, so you can load different kinds of embedding model. So here I'm going to load OpenAI embedding model. So OpenAI is having also embedding model. You can see OpenAI embeddings. Okay, embedding models. So it is having different embedding model. See, text embedding 3 small, text embedding 3 large, text embedding ADA. So that's how it is having different kinds of embedding model. Okay, so let's load one embedding model. So by default, I think it will load this model, text embedding ADA. Okay, this model maybe it will load by default. So let me load this embedding model. Okay, that means what will happen? So here we'll be using embedding model. So let's say this is my embedding model. Okay, embedding model. And he will be giving the input text. Input text. Okay, and this will return you the vector. Vectors embedding. That means numerical data. Okay, numerical data. Okay, so that you can store it to the vector database. Vector database DB. Okay, this is the idea. Now let me show you. So let's say here I'll be taking list of the sentence. Okay, so chunks of text we are having. Let's say hi there, hello, what's your name, okay, James Bond, and so on. Now we'll try to convert these are the sentence to the numerical representation. So for this I'll be passing this list to the vector embedding model. You can see embedding model dot embed document. So this document I'm passing inside the embedding model, and it will give me the embeddings. Now you can also see the embeddings. Let me show you. See, this is the embedding, guys. Now you can see this is the numerical representation. Okay, numerical representation. I can see it's a minus 0 you are having. You can also see the plus 0 as well. Okay, that means it's a coordinate. So it has created one higher dimensional coordinate space. So that's how it has created one coordinate space. Okay, and these are the coordinate number. Okay, like minus coordinate, plus coordinate, I think you know. That's how it is storing the vector. Let's say this vector will store here, another vector will store here, another vector will store here, another vector will store here. Okay, that's how it is storing the vector in the multi-dimensional space. Okay, based on that it will decide which vector is closely. Let's say these are the vector are close, then these are the vector are close. Okay, these are the vector are close. So that's how it will make a cluster. And whenever you are doing the similarity search operation or vector search operation, that's how it will identify. Let's say if there is another vector, let's say this vector is there. Now this vector is close to this particular cluster. That means this cluster it will consider. So that's actually it is performing similarity search operation. I can see this is the vector representation, entire vector representation of your data. Okay. Now if you want to see the dimension, what is the dimension of the OpenAI embedding? So this is the dimension. You can simply check the length. See, 1536 dimensional vector you are getting. That means one sentence. Okay, one sentence is representing in the 1536 dimensional space. So as a human, we can only visualize 3-dimensional, guys. This is a 3-dimensional, but our data is storing 1536 dimension. Okay, it has created 1536 dimension. Okay, in that space actually it has stored all of my embeddings, all of the vector. So as a human being, it's not possible for us to visualize that one. Okay, I hope you got it. So now let me open up my code. Now if you want to see the first 5 numbers, you can also do the list slicing, because at the end it's a list. Okay, you can see the first 5 number. Okay, yeah, and these are like a pre-trained model. Okay, the model actually we are using, these are the pre-trained model. So that's why these are the vector is pretty good. If you give to the model, so model can understand easily. Okay, this is the idea. So we have learned how we can perform the splitting operation, and we have also learned how we can convert our text to the embeddings. That means vector representation with the help of embedding model. Now the next thing we'll be learning about vector store. Okay, we'll be learning about vector store. Vector store, that means vector database. So there are some vector databases are available, like ChromaDB is there, Fice is there, Pinecone is there, WebAT is there. Okay, then PostgreSQL is there. Nowadays actually Red Hat also created the vector database. That's how we are having different kinds of vector database. So let me show you some of them. So what is vector database? Vector database is nothing but it stored the embedding in a very fast searchable, it stored the embeddings in a very fast searchable database. Okay, this is called actually vector database. Now let me show you some of the example of the vector database. First of all, let me show you the ChromaDB example. So this is the ChromaDB. You can see if I want to plot the ChromaDB, guys, if I want to import the ChromaDB is already available inside Langchain Chroma. Now if I open the requirement.txt, so Langchain Chroma we haven't mentioned. So first of all, we have to install one package. So this is the package, guys, we have to install called Langchain Chroma. Okay, so try to open up your terminal and try to install the requirements again, then it will install the Langchain Chroma. So Langchain, what they did, they created separate library for the vector database. Let's say you want to use Langchain ChromaDB. You have to install Langchain Chroma. Let's say you want to use any other vector database. That time you have to install with respect to that name. Okay, so that's how they have created different kinds of functionality. So here we are importing the Chroma from the Langchain Chroma. You can see. Then we are loading the text loader. That means we'll be loading the text embedding model, because first of all I have to generate the embeddings from the text. And why splitter? Because my data would be huge. Okay, first of all I have to create the chunk. Okay, with the help of that chunk actually we'll be creating the embeddings. That means it's a step of execution, guys. Try to remember, first of all you have to load the data with the help of text loader. Then you have to perform the splitting operation. That means you can see I'm performing the splitting operation. After splitting we are getting the chunk. So with the help of embedding model we'll be creating the vector embedding. Okay, and this particular vector embedding will be storing to the vector database. So this is the step of the execution. So here I have already written, I think, remember. So here split numerical representation, then load the embeddings to the vector database. Okay, then we'll be getting the retriever. Then we can perform the RAG operation. That means we can perform the query operation on top of it with the help of large language model. So here is the example. First of all, I'm loading the data. So I'm loading this data actually. So inside the data, I'm having one file called state of union.txt. So state of union.txt. So this is the data actually I'm loading. Okay. After that, I'm performing the character test splitter, and chunk size 1000, chunks overlap 0. I haven't given any kinds of chunks overlap. Then I'm splitting the data. Okay. Now let me show you how many chunks you will be getting. So this is the chunks. See, you are getting so many chunks. So let me show you the length. You are getting 42 chunks here, guys. 42 chunks you are getting. Okay. Now this thing, what I will be doing, will be generating the vector embedding. Okay, and will be storing to the ChromaDB. And ChromaDB is nothing but it's a local database. So it will store everything in your memory. In memory it will store the data, guys. Okay, always try to remember ChromaDB is a local vector database. So for this you have to give the chunks, okay, inside the ChromaDB. So there is a function called from document. You have to give the entire chunks, and you have to give the embedding model. So what it will do, it will take the embedding model. That means it will perform this operation. It will take the input data, it will take the embedding model, it will give you the vector store. Okay, vector embedding, and it will store to the vector database, which is nothing but my ChromaDB. Okay, so this is what actually we are doing in this line. And with the help of one line actually we are able to perform, because we are using Langchain. Okay, if you are not using Langchain, that time you have to write the manual code. So that's why actually we are using Langchain. Langchain is a complete orchestration framework. So it will give you all kinds of functionality, so that with the help of very less line of code, you can perform all the jobs. Okay, now let me execute. See, it is storing. It is converting all of the data in the like vector representation, and it will store in the vector database. Okay. Now, see, it has loaded. That means this vector DB, this is my object right now. This is my vector database object right now. You can see this is an object. Now I can perform similarity search operation. Okay. That means, let's say here I'll be asking one question. What did the president say about the John Lewis Voting Rights Act? So if you open this documents now, so it is related this John Lewis and all. So these are the information we are having. Now here what I'm doing, I'm calling the vector database object, and I'm performing similarity search operation. So this question I'm giving, that means what will happen? So whenever you are asking this question, it will go to the knowledge base, that means to the vector dimension, and here it will search the similar results. Okay, similar results from this particular vector, and it will give you the similarity response. Now let me show you. So these are the similar results I got, guys. 4 similar results you got. Okay, but I don't want this kinds of output. I want the exact output. So the question I have asked, I want the exact output. Let's say this question, if I ask to the ChatGPT, okay, if I ask to the ChatGPT, ChatGPT will give me the exact answer, yes or no. See, it will give you the exact answer. Okay, exact answer. What is the answer actually you are looking for? But in case here I'm not getting the exact answer. Okay, I'm getting the similarity answer only. Okay, so how to get the exact answer for this? Will be connecting our large language model. So whenever we'll be creating the RAG, that time I'll tell you, okay, how to connect the large language model. As of now, we are only doing the similarity search operation. Okay, this is the idea. Fine. Now there is another way you can retrieve the information. So this is called actually retriever. Let me show you one retriever example. vector store as retriever. That means finding the embedding and the best answer your question. So it will give you the retrieve output. Even it will also show you the metadata, that means source document, like from where it is retrieving the data. So let me show you one example. So what I will do now, let me show you another vector database example. So first of all, let me load one data. So I'm loading the state union txt again. Then we'll be using FIAS. Okay, FIAS is another vector database. You can see FIAS is another vector database. Again, it's a local vector database. Okay, it will store the data locally. Now again, I'm importing OpenAI embeddings and character text splitter. First of all, loading the documents, doing the chunking. That means creating the chunks, doing the splitting operation. After that, initializing the embedding model. And you can see inside FIAS, I'm giving the chunks as well as my embedding model. That means it will convert my text to the vector embedding and it will store to the vector database, which is nothing but FIAS. Okay, and it will give me the vector DB object. So this is the vector DB object. Okay, now we'll be creating something called retriever. How to create the retriever? That's how we can create the retriever. Vector DB, there is a function called as retriever. Okay, as retriever. See, always try to remember, whenever you are creating RAG based application, you have to use this function as retriever, not the similarity search. Okay, similarity search. So we won't be using this method. We'll be using this method because this is more powerful. Why? Let me show you. So let me ask one question. So I'll be asking this question. The retriever.invoke, what did he said about Ketanji Brown Jackson? Okay, let's say this is my question. Now, if I show you the response, see, it will give you by default 4 response. Okay, 4 response, 4 retrieved output. Now you can see it is also giving you the meta sources, like which document it is referring, from which page content it is giving you the information. See, it is giving each and everything. Okay, these are the most relevant answer it has filtered out from the txt document, the documents actually you have given. Okay, see, it is referring this document actually. Okay, so that's why it is more powerful than your similarity search, because similarity search is not giving this kind of particular metadata information. But I want to understand which document it is referring, which line it is referring. Okay, if I want to understand, I'll be using the retriever at that time. I hope it is clear. Okay, now if you want to see the length, simply you can also see the length. So here it has given me by default 4, because add retriever, it will give you by default 4. Okay, 4 response. You can also tweak this parameter. For this, there is a parameter called top k. I'll tell you how to change the parameter. So let me show you how we can change the parameter. So whenever I created the retriever, so here I can mention this parameter, search keyword. Here, search keyword k is equal to, so here if I give 2, it will only give me 2 answer. Let me show you. See, now it has given me 2 answer only. Okay, 2 retrieve output. If you give 3, it will give you 3 answer. So this is called k parameter. Okay, see, 3, but by default they said 4. Okay, it will give you 4. If you give 1, it will give you only 1. Okay, so what we have learned? First of all, we have learned that a text is splitter. That means we have learned about the splitter, how to create the chunks. If you are having bigger document, how to convert into the smaller chunks. After that, we have learned how to do the embeddings. That means we'll be using some embedding model. Okay, with the help of that, we'll be generating the vector embedding. After that, we learn how we can store these are the vector embedding to the vector database. Okay, I showed you some example of the vector database. Then we have learned how to perform the similarity search operation here. Okay, then I told you we'll be using something called retriever, because retriever is more powerful, because retriever gives me the sources. Okay, sources as an output as well. Okay, so this thing actually we have learned. Now with the help of these are the components, we'll be creating one RAG system in the next class. This is the agenda. So guys, now we'll be implementing one basic RAG. So here we'll be using Langchain expression language to implement this RAG application. No need to worry, I will discuss more about this Langchain expression language. This is just an introduction. I will show you how we can implement the RAG application. Okay, so on top of this Langchain expression language, I'll be taking the dedicated actually session. So there I'll try to discuss each and everything. Okay, as of now, I'll give you the high level overview. If I want to implement any kinds of RAG application, so how we can use LCL. Okay, and whatever things we have learned so far, whatever RAG component we have learned so far, we'll be integrating all of them all together. Then we'll be implementing this particular RAG application. So inside RAG component, you are having these are the component. So first of all, you have to split the data, then you have to generate the embeddings with the help of embedding model. Then you'll be storing that embedding to the vector store, that is vector database. Then we'll be creating the retriever. And if you want, you can also set the top k parameter. Then what you can do, you can perform the retrieve operation. Either you can perform similarity search operation. But whenever actually I was performing the retriever operation, similarity search operation, so it was only returning the similar kinds of response. Okay, like the best results, actually it was returning around 4 to 5 response it was returning, but that is the answer I'm not looking for. I'm looking for one accurate response. So if I want to get the accurate response, guys, what I have to do, I have to connect my large language model. Okay, after connecting the large language model, we'll be able to get the correct response from the let's say custom documents, whatever I'm asking. So this thing I'm going to show you how we can connect our large language model with our custom data. Okay, so first of all, I will draw the architecture, what we are going to perform. Then I will start with the coding. So here we'll be implementing one basic RAG. Okay, and whenever I'm talking about RAG, that means I'm talking about my custom data. So it can be any kinds of document. So let's say here I can consider custom. Okay, custom data. So it can be any kinds of data format. It can be PDF, it can be TXT, it can be Excel, XML, JSON, anything you can consider. Okay, so I'm just calling as a custom data as of now. So first of all, what I have to do, guys, this custom data, anyone remember? If I want to perform the RAG operation, so I can't directly pass this data to my LLM. Okay, so for this, first of all, what I have to do, I have to perform the splitting operation. So we'll be performing the splitting operation. Okay, splitting, or you can also call it a chunking. Chunking. So after getting these chunks, what I will do, we'll be using one embedding model. Okay, embedding model. So in case you can use OpenAI embedding model, you can also use some open source embedding model, you can use Grok API, it's up to you. Then after that, we'll be creating vector embedding. Okay, we'll be generating the vector embeddings. Then we'll be storing this vector embedding to the vector database. Vector store, or you can also call it as vector database. So this will become my knowledge base. This will become my knowledge base. Okay, then what will happen, user will, let's say this is the user will ask some query, and your vector is stored. That means you will be creating a retriever here, retriever. Okay, retriever here. So it will give you some rank results. Rank result. Okay, based on the k parameter. So here I can write top k. Okay, based on the top k parameter. So let's say it has given you 3 response. Okay, 3 response. Let's say k is equal to 3. It will give you 3 response. Now I don't need the 3 response. I need accurate response. Okay, let's say here I'm asking. Let's say here I'm asking. Let's say what I can ask. Let's say what is the capital of India? So as a return, guys, what should I get? Okay, as a return, what should I get? Definitely Delhi, right? So it should give me the Delhi, but here it is giving me some rank results. So let's say it is giving some content related Delhi, and apart from which is, let's say, relevant to the Delhi, it is also giving me that one, but I don't need. I need the accurate response. So for this, what I will do, I will use my large language model. So here we'll be using large language model, LLM. Okay, so in case actually we'll be using like ChatGPT model, but you can use also any other model. You can use Grok API, it's up to you. So here what we'll be doing, so the rank results actually we are getting, so we'll be passing this rank results to my LLM. Okay, we'll be passing this rank results to my LLM, and whatever question user is asking, okay, the question also I'll be passing to the large language model. And now what will happen? Large language model got the context. So this is called context. This is called context, okay? And this is called query. This is called query. I think you remember. I showed you one example. So here, let me show you. So here, I think data loader rag demo. Wikipedia loader. I think whenever I was talking about Wikipedia. So here, can you see here what I was doing? I was searching about Tesla, and whatever data actually I was getting, I was passing as a context, okay, to my large language model. Then I was also giving the question, like, tell me about the Tesla, the same thing. But now what we are doing, we are doing some more step because my data size is huge. So first of all, I have to split the data. Then we have to create the embeddings. That embeddings will be storing to the vector database. Then what we'll be doing, user will give some query, and this query actually will go to the knowledge base. Knowledge base will return some rank results, and this rank results I'll pass to my large language model as a context as well as the query. Now LLM will process, okay? LLM will process, and it will generate a accurate response. Okay, accurate response for you. So to the user. Okay, to the user, it will give me the response. Okay, so this is the entire RAG architecture. Okay, I hope it is clear. So as of now, we have created till retriever. Okay, we haven't connected our large language model. Now we'll be learning how we can connect the large language model. Okay, so now let's try to implement this architecture through our code. So let me open up my VS Code, and here I'm going to create a file. So let me name it as 05 rag, basic rag, implemented. So the first thing what we usually do, guys, first of all, we'll be loading the OpenAI API key from my environment, because here I'm going to use the ChatGPT model. You can also use Grok model. Okay, Grok. You can also use Grok API to load the model. Now the next thing, rag component, and there I showed you the retriever, how to create the retriever. So first of all, we load the data, then we perform the like chunking operation, that means splitting operation. Then we use embedding model. We create a vector store with the help of vector database. Then we create the retriever. And whenever you are asking something into the retriever, it will retrieve some relevant information, okay, with the help of metadata as well. Okay, so till here we have done. Now we'll be learning how we can connect the large language model. That means the information I'm getting from my retriever, I'll pass to the LLM, as well as I'll also pass the query. Okay, whatever query user is asking, based on that, LLM will try to process and it will give you the accurate response. So for this, you can see this code is already familiar with you. So I'm importing the FIAS. FIAS is a vector database. Then OpenAI embedding, because I need an embedding model to generate the vector embedding. Then character text splitter I need for creating the chunking. Okay, so let me import all of them. So first of all, I will load the data. So let me load one data. But before loading the data, I need to import this library as well. So text loader. So I'll be loading one txt documents. So this txt document will be loading a state of union txt. So let me load it. So this is my data. Now you can also see this is the entire data we have loaded. Okay, now the same next thing will be creating the chunking. We'll be doing the splitting operation. So this is the code snippet. So here you can see I'm given chunk size is equal to 1000, chunk overlap 0, and whatever document I have loaded, I'm passing to the split document. Now it will give me the chunk. So you can see the complete chunk. See that many of chunk it has given me. If you want to see the length, you can also check the length. So 42 chunks it has given me. Okay, then what we'll be doing, guys, will be loading the embedding model, and we'll be creating the vector embedding, and we'll be storing in the FIAS vector database. Okay, so let me do it. So it has created one vector database, and it is storing in your disk, okay, local disk. And now we'll be creating the retriever. So this is my retriever, guys. Okay, and by default, how many retrieve parameter actually it will have? I think you know. By default, it will have 4 retrieve parameter. Okay, 4 retrieve parameter. You can also test. So let me show you. So I'll be asking one question. So retriever.invoke, what did he say about Ketanji Brown Jackson? So if you open this documents, so you will see the information related Ketan G Brown Jackson. Now if I ask it, so it will give me some response. See, it has given me 4 relevant response. Okay, now you can also play with this parameter. So I think you know there is a top K parameter you can set. Starts KW is equal to K is equal to 1. That means it will give you only 1 information. Okay, so let's say I want to take 3. Okay, 3 information. Now if you ask the question again, now see guys, your response would be 3. Okay, you can see you got 3 information. Okay, now you can play with this parameter. It's up to you. Fine. Now we'll be creating the RAG. That means we'll be connecting our large language model right now. And here we'll be using Langchain expression language. Simple use with Langchain expression language. Okay. And today I'm not going to discuss like this Langchain expression language. For this, I'll be keeping one dedicated session. Okay. So now let's create the chain. So before that, first of all, I need to import some library. So here is the library, guys. So first of all, I'm importing chat OpenAI. Why? Because we'll be using chat GPT model. That means GPT 3.5 turbo model. And I'll be using chat completion model, not the completion model. And chat prompt template. Why chat prompt template? I think you know, whenever I want to give any, let's say, input to my large language model, that means if it is a chat like a completion model, that time I also need to pass the system prompt. Okay, system prompt as well as the user prompt. So for this, we'll be using the chat prompt template. We'll be creating the prompt template. Okay, then we'll be passing the prompt. Then this is the new thing, guys. Langchain has proposed. It is available in the second generation language, Langchain, which is called Langchain expression language. And to perform it, you need these are the library: str output parser and runnable pass through. Okay, there are some more, let's say, functionality they have created. I will discuss each and everything. As of now, just try to get it as a high level. So if you want to use this Langchain expression language, you need these are the functionality from the Langchain. Okay, Langchain core, output parser, output str output parser, and runnable is equal to runnable pass through. Okay, now let me import all of them. Now, first of all, I'll be creating the template. So this is my prompt template. So first of all, I'll be creating the prompt, then I'll be creating the prompt template. So this is the prompt. Answer the question based on only the following context. That means user will give the context. Context means the retriever. Okay, the vector database. Okay, this context as well as the question. Okay, so here I've already written the diagram. So it will first of all give the context to the LLM as well as the question, whatever question user is asking. Okay, now if I want to create the prompt template, I'll be using this chat prompt template function. So see guys, chat prompt template, and here I have to give the template, and this will give me the prompt. Okay, now I'll be initializing my OpenAI model. So here we'll be using chat OpenAI. That means we'll be using GPT 3.5 turbo model. Okay, great. So let me execute. Now here I'll be creating one function. I'll tell you why we are creating the function as of now. Just try to remember this function will format the output. Okay, so now this is the chain, and you can see the syntax is written with the help of LCEL. That means Langchain expression language. See, chain is equal to, I have given a bracket. Again, I have given a bracket. Now here I'm writing the context is equal to retriever, because you remember what is context? Context is nothing but my rank results. Okay, the retriever. So this thing I have to pass to the LLM. So you can see this is the retriever I'm passing. And format documents, this function object I'm giving. Okay, format documents, and question is equal to runnable pass through. Okay, now you will have some doubt. I know that initially if you're starting with this Langchain expression language, this would be confusable for you. No need to worry. In the next session, I'll try to discuss each and everything about this Langchain expression language. As of now, just try to remember whatever input user will provide. Okay, this input will come here as it is, and it will save inside the question. Okay, question actually a parameter. Then the prompt we have prepared. See, this is the prompt we have prepared. Then the model then the output parser. That means what is happening, let me show you. So I'll open up my annotator pen. Let me select the color. See, first of all, you are see, you have given the bracket. So this bracket is called parallel. Okay, parallel runnable. I'll tell you what is parallel runnable. It will run everything as parallelly. You can see I have given too many statements. So this is the first statement, retriever. This is the second statement. That means the function object. And this is the third statement, which is nothing but the input. Now you can see here is a pipe symbol. And what is pipe symbol? This is the LCL symbol. LCEL. Langchain expression language. Okay. So with the help of this pipe symbol, we create this actually chain. Okay. Now I'm giving the prompt model as an str output parser. So what will happen? First of all, you are executing this one actually. Okay, that means your context and input will come. So let's say user has given what is Tesla. Okay, what is Tesla? This is the question. So this question, where it will go to the prompt template, and it will create the prompt template. I think you remember. So how to create the prompt template? That's how it will create the prompt template. So answer the question based on the following context. So context with that means retriever. Retriever will come in the context, and question, whatever question, let's say what is Tesla? Tesla will come inside that question. Okay. Now this question, where we have to pass to the model. You can see we have to pass to the model. That means this question will go to the model. That means my large language model, and model will give me what? It will give me response, yes or no. Okay. And I think you know, whenever we are getting the response from the LLM, so what format it will return? It will return as a AI message format. Okay, but I only need the content of it. And if you only need the content, you have to use this str output parser. I think we have already learned output parser. Remember, inside I think data loader, not data loader. I think inside this one, talk with LLM part 2, we have learned about output parser. So with the output parser, we can format our output. That means if I want to get a JSON output, if I want to get a TXT output, everything you can customize here. So this output parser will by default will return as a string output, str. Okay, str. Okay, so this is what actually we are using. That means first of all, we are giving the context, then we are taking the input from the user, we are saving into the question variable. Okay, then format documents. What format documents will do? Whatever response actually it will give you. Let's say, see what happens actually whenever we perform the retrieve operation. Let me show you. So here is the retrieve operation. See, whenever we perform the retrieve operations, what happens? It will give you, these are the retrieve output. Okay, these are the retrieve output. But here what I need, I only need the page content. I don't need the metadata information. It's not required. I only need the page content. So what will happen? This function will automatically filter out only page content. Okay, I don't need the metadata. I only need the page content. So this will extract the page content and it will return. Okay, here. Okay, and this input will go to the model. Okay, first of all, it will create the prompt, then it will go to the model and it will give you the output. Now let me show you. So here I'll be asking one question. So the same question will be asking chain.invoke, what did he say about Ketanji Brown Jackson? Okay, now let me execute and let me show you the response. See guys, this is the response, and if you see the type, it will be string. Okay, it says str because of that output parser. Okay, so this is what our basics LCEL, that means Langchain expression language. Okay, but previously I think you remember, those who have already worked with this one older version of the Langchain, we used to use chain functionality. I think remember chain functionality. We used to import I think chain. Okay, instead of using the like default chain from the Langchain, we have created the Langchain expression language. And see, always try to remember, it's not like that this inbuilt chain has been deprecated. No, still Langchain suggests to use that chain as well, chain functionality as well, because still chains is under development. Okay, still the chains under development. That's why Langchain is also suggesting you have to use the older technique if you want to create any kinds of project. I'm getting the correct response right now. Okay, from my application. Previously it was only giving me the related information. Now I connected my LLM. Okay, now if you ask any kinds of query, it will give you the accurate response. The architecture we have drawn, see, accurate response it will give you. So guys, now I'm going to discuss about the memory inside Langchain. So I think you saw nowadays actually whatever applications are coming actually inside generative AI, all the application have this memory functionality. So let's say if I'm talking about ChatGPT, so when you are asking something to the ChatGPT, so this will remember that particular context. Let's say I have asked, hi, my name is Bappi, how are you doing? Okay, now next time if you're asking what is my name, so you'll see that ChatGPT will reply, your name is Bappi. That means your conversation, whatever conversation you are doing, whatever, let's say, prompt you are giving, it is trying to remember that particular context. It is trying to remember that particular, let's say, data. Okay, so how it is doing? It is using something called memory. Okay, memory. We have two kinds of memory. One is like temporary memory. One is like permanent memory. So both of them I will discuss. No need to worry. And this is called actually memory management. So make sure whenever you are implementing any kinds of application, okay, generative AI application, so you should include this particular memory management, okay, in that application. Otherwise, what will happen? It won't be able to remember the user input. So this is super important, guys, this memory. So let's try to discuss this memory, okay, how we can use it with the help of Langchain. If you open up the ChatGPT, and inside ChatGPT, if you ask any kinds of question, let's say if I ask, let's say, hi, my name is Bappi, I love coding. Okay, so let's say this is the question I have given to my ChatGPT. Now ChatGPT has given me one response. Okay, now if I ask, let's say, what is my name? Okay, now see, it is telling your name is Bappi. That means it is remembering my previous conversation, okay, previous context. So whatever, let's say, prompt you are giving, whatever response actually you are getting, it is trying to remember that thing. So this is called actually memory. So these kinds of memory we are having inside the LLM powered application. So whenever you are creating your custom application, you also need to implement these kinds of functionality inside your application, okay, so that user experience would be better. So let's say if I'm asking something, so I don't need to again repeat that question again, okay. So this is super important whenever you are creating this application. So this thing we can handle with the help of Langchain memory. So today I'll show you the Langchain memory, okay. So two kinds of memory we'll be learning, the permanent memory and we'll be learning about the temporary memory. Even going forward, whenever we'll be creating some application, that time I will also show you how we can save those conversation, okay, in a file, okay. So it is also possible. So we can also save the memory in a file. Got it? Great. So let me write down the agenda, whatever things we're gonna cover in this session. So here, agenda, we'll be learning about memory, okay, memory in Langchain, okay, memory in Langchain. But before starting with memory in Langchain, I just need to discuss some of the very important concept. Just a minute, guys, let me discuss. Okay, so I already created documentation for you. So these are the things you have to remember if you are working with memory inside Langchain. Okay, so I was going through the documentation and I got to know these are the information. So that's why I thought let's save it so that I can also show you. See, memory is what? Save your conversation with the LLM. That means whatever conversation you are doing with your large language model, you can save those conversation. Okay, so this is called actually memory. Now if you see, ability to share the information about the past interaction, that means whatever let's interaction you are doing, previous interaction you are doing, so memory helps us to save those information. Okay, that means if I'm asking something related that, it will be able to remember. Now you will have some control. Let's say how many conversation you want to save. You want to save the entire conversation or you want to save some specific conversation, some number of conversation. So these kinds of parameter we are also having. So I'll be discussing, no need to worry. Then you can see most of the memory related functionality in Langchain is marked as a beta. Okay, this is for two reasons. Most functionality are not production ready. Most functionality work with the legacy chains, okay, not in the newer LCEL syntax. That means inside Langchain expression language, you can't use this particular memory functionality. Okay, if you're using memory functionality, you have to use the legacy Langchain. You can see here. Sorry, let me change the current. See, you have to use the legacy Langchain. So see, Langchain also like suggesting if you're working with the memory inside Langchain, just go with the legacy Langchain. Okay, because still it is under development. They are trying to integrate this thing with the Langchain expression language as well. Maybe soon actually they will also integrate and they will also make it as production ready. But as of now, if you want to create any application, if you want to add the memory functionality, you can go with this legacy Langchain. Okay, because see, legacy Langchain is still, it is not deprecated, so still you can use it. So because Langchain is also suggesting you to use, so no need to worry about. And you can see it is still marked as a beta. That means it's not a production ready. The memory, let's say they have created, okay, it's not a production ready. But again, this is some important actually component inside Langchain you'll be getting, because memory functionality at the end we have to add inside our let's say application. So that's why you can use it. Still it will be work in the production. Okay, don't need to worry. Apart from that, we are also having some alternative. Let's say instead of using this memory, you can also create your custom memory. It is also possible. You can also use some in-memory database. Let's say Redis is there. Okay, with the help of Redis also, you can create your own memory. It is also possible. Okay, so for this you should have some additional knowledge, okay, on top of some additional tool. But as of now, still Langchain is suggesting to use whatever, let's say, functionality they're having inside memory with the help of legacy Langchain. So going forward, whatever example I'm going to show you, I'm going to use the legacy Langchain, okay, not the Langchain expression language syntax. Now the main exceptions to this chat message functionality is the functionality is largely production ready and does integrate with the LCL. Okay, that means see, there is another actually functionality will be getting called chat message story. Okay, this functionality is largely production ready and does integrate with the LCL. That means you can also integrate with the LCL, but this one is like a little bit different. I'll tell you. So as of now, I'm not going to show you the clear-cut example of it, but I'm going to at least show you some demo how we can use the chat memory story. But going forward, whenever we'll be creating the project, okay, that time I'll tell you, okay, how we can use it like properly. But if you're a beginner, if you want to start with your application development, I will suggest go with this one actually. The things we'll be learning today, that means with the help of legacy Langchain, because you will already have some predefined function for the memory. We are having the buffer memory, okay, buffer memory, and we are having the chat message story memory. So both will be exploring one by one. Okay, now if you want to see some documentation of this memory, so let me open some documentation, guys. You can see still they are telling it's a beta, okay, beta version of the memory. See, in the documentation they are mentioning, so it's a good practice. Just go with the documentation as well if you're working with something, because see, if you're not understanding the entire documentation, what you can do, at least you can search here. See, Langchain is also having the search option, so simply you can search here. Let's say I want to use the memory, okay, memory inside Langchain. So simply search here, you will see memory will be getting different memory will be getting. Okay, now simply you can open up an example, you can try to learn the memory. Okay, so chat models LLM model memory. So here you can go to the beta memory, this one. Okay, so that's how we can read, and you can see they're using legacy Langchain, okay, the older version of the Langchain. See, so we are having some functionality of the memory, and if you want to use them, you have to use the legacy Langchain. See, they are using the chain predefined function, and this is called legacy Langchain. I think I showed you some example previously, right? So inside that you can see they're using this buffer memory and all. Okay, so there is no example of this latest like second generation of Langchain, like LCL, Langchain expression language. And if you want to see the example of chat message history with LCL, so this is the documentation. So here, guys, you can see template, message placeholder, history, human input, add message history to the memory. See here, I think chat memory history. So for this you have to create a custom function, okay, then you can use that one. You can save as a like memory, okay, memory kinds of thing. So this one we'll be learning whenever we'll be doing the project, that time we'll be learning. Okay, today I'll show you a basic example, then we'll be learning later on. So first of all, let's try to export this one, our most used actually memory inside Langchain called buffer memory. Okay, like what is buffer memory and how we can use the buffer memory. This thing will be exploring. For this, I'm going to open up my code editor, and here let me create a file. I'm going to name it as 09 memory Langchain .apy and b. So the same thing I'm going to do. First of all, I'm going to connect my kernel. Then I'm going to load my OpenAI API key. You can also use your Grok model. It's up to you. Then after that, I'm going to load one LLM. That means I'm going to use the chat completion model. Okay, the same model like GPT 3.5 turbo model we'll be using. Now the first thing we'll be exploring about the buffer memory. So this is the buffer memory. Okay, buffer memory example you can see. So buffer memory is nothing but it's a it keeps a list of the chat messages in a buffer, okay, and passes those into the prompt template. So let me show you one example. For this, first of all, let me import some library. So guys, I think you are already familiar with these are the library, like we're importing chat prompt template, message placeholder, system message prompt template, human message prompt template. Why? Because as I told you, we'll be using legacy Langchain. Okay, legacy Langchain, and I already showed you legacy Langchain example. Let's say if I want to create the system prompt, because we are using the chat model, right? We have to give the system prompt as well as the user prompt. So system prompt wise, we'll be writing inside system message prompt template, and human message prompt wise, we'll be writing human message prompt template. Okay, this is the idea. Now here we are importing this particular LLM chain, because here we are not going to use the second generation of Langchain. We are not going to use the pipe symbol. We'll be using the custom made chain, okay, chain functionality inside Langchain. And this is the conversation buffer memory. That means this is the functionality we'll be using. Okay, with the help of that, we can save the conversation. Now let me show you one example. So here, first of all, we'll be creating the prompt. So this is my entire prompt. You can see chat prompt template, inside that message, and this is the system prompt. So first thing, we have to create the system prompt. And you remember, you had a nice chatbot having a conversation with a human. So this is the prompt I'm giving as a system. And message placeholder. Okay, what is message placeholder? Because if you go to the documentation of Langchain, if you go to this buffer memory, so they're suggesting you have to use this particular syntax. That means the chat history. That means whatever conversation you'll be doing, this is called chat history. Okay, so this chat history, it will try to remember. So that's why you have to specify this name. So make sure guys, you are giving the same name, otherwise you will be getting issue. And this is the human message prompt template. That means whatever question user will asking, okay, it will come here. Got it? Now we'll be creating the chain. We'll be creating the memory. So this is the memory, conversation buffer memory. We are using this function. Inside that, we are giving the memory key. That means I'm telling I want to only save the chat history, okay, and return message is equal to true. That means you can also see the conversation, okay, like you can also see the execution log. So that's why we are given return message is equal to true. Okay, now let me show you how it will work. So for this, let me create a chain. So this is my final chain, guys. You can see this is my final chain. I'm using LLM chain. Inside that, I'm passing my large language model. The large language model we have imported, and I'm giving the prompt. The prompt we have prepared. Then I'm giving verbose is equal to true. That means I want to see the execution log, and this is the memory. Okay, the memory we have created. Now let me create this chain, and see you are getting the warning because you are using the legacy Langchain. Okay, deprecation warning you will be getting. Now let me ask one question. So this is the question I'll be asking. Let's say first question I'll be asking hi. Now you can see that it has executed my chain. So question was hi, and chat history I got. Inside chat history, that means the keyword we have given chat history. So inside chat history, you can see hi has been set. Okay, hi has been set, and my model has replied hello. You can see hello, how are you today? So this is the response I got. Now let me give you another. Let's say question. So this is the question. Here I'm giving my name is Bappi and I have moved 33 times. Okay. Now this is another question. Now you can see this is my question. My name is Bappi. I have moved 33 times. Inside chat history, the previous conversation, it is already saved. You can see hi. That means the previous conversation we asked hi. Now this was the response. Now again, human is asking, my name is Bappy, I have moved 33 times. That means the question you are asking, and this is the response I got. Okay, that means it is remembering my previous context, the question actually we asked, okay, in the chat history. Now let me ask another question. So this is the another question. If my average moving distance was like 100 miles, how many miles took all my moves? So this is my question. Now we'll see that it will remember this particular conversation as well. Like, my name is Bappy and I have moved 33 times. You can see inside. So you can see this is my current question, and this was my chat history. Hi, this was the response. Again, this question I asked, then this was the response. Okay, now this is the current question I'm asking. Okay, and this is the current response I'm getting. Now see what is happening here. What is happening? See, it is using the entire actually prompt. That means the previous conversation also it is passing as an input to the model. That means whenever you are asking something, let's say whenever I'm asking something, let's say this is my LLM. This is my LLM. So the first thing I have asked about hi. Okay, hi. So it has given me how are you. Okay, how are you? Then again, whenever I'm asking the second prompt, let's say my name is Bappy. Okay, I'm asking my name is Bappy. So first of all, it is going like that. Let's say hi, how are you? Okay, how are you? Then my name is Bappy. My name is Bappy. So this is going to be the input prompt right now, and it will give me another response. Okay, then whatever response you are getting, again it will add the response with this particular prompt. That means every time whenever you are asking the question, every time whenever it is saving the conversation, it will pass this conversation as an input to the LLM. That means if you are doing, let's say, multiple conversation, like the conversation, let's say you are continuing, at that time your input prompt is also increasing, and whenever input prompt is also increasing, I think you know how ChatGPT, OpenAI charges based on the input limit token, right? So based on that, actually it will charge you more. Okay, that means here you don't have any control. So as much as conversation you can perform here, and it will remember all of the chat history. So it's not an efficient way, because I need some certain actually question. I need some certain conversation. Let's say around 5 to 6 conversation. I want my model to be remembered. Okay, because whenever you are creating any kinds of real world application, let's say ChatGPT, so user will ask, let's say 3 to 4 times. Okay, the conversation they are doing, they are not, let's say yesterday whatever things they did, they won't be asking that one. Okay, they will be creating a new chat. I think you are getting my point, right? So that's why we always need to specify like how many conversation my application should remember. Okay, so these kinds of functionality you don't have here. The method we are using, this buffer memory you are using here, we don't have this particular method. Okay, for this we'll be using another technique, I'll tell you. But before that, so let me show you whether it is able to remember my name or not. So here I'm asking, I think you remember I have given my name here. So here my name is Bappy and I have moved 33 times. Now here I'm asking, do you remember my name? So it will tell me, yes, it remembers my name. My name is Bappy. How it is remembering? Because it has the entire chat history, entire conversation, okay, with it. That's how actually it is remembering. I hope it is clear, guys. Now how we can use the memory. Now you can see the buffer. Like buffer means the buffer means it is saving everything in the RAM. Okay, your whatever RAM you are having, your memory, it is saving. See, you can see this is the question we have given. So see, all the conversation it has saved. Okay, but this is a temporary memory. Let's say if you close your application, again this memory would be disappeared. That means everything would be deleted, everything would be clean. But how we can save it as a permanent, that thing I will show you. Whenever we'll be creating one application, that time I'll show you how we can save this an information in a file. Okay, you can save in a JSON file, you can save in a YAML file. Everything is possible. Okay, so to prevent this issue, we can use another function from the Langchain called conversation buffer memory, buffer window memory. Okay, so here you can mention the window limit, like how many conversation you want to save. You can see similar to the previous one, but you can limit the number of conversation actions stored in the memory. For example, you set it to the set it so it only remembers the last 3 questions and answered of the conversation. Okay, so let me show you one example. So first of all, let me import. You can see I'm importing this conversation buffer window memory and the chat conversation chain. Now first of all, let me create the memory. Now we'll be creating the window memory, and k is equal to 3. That means it will only remember my 3 conversation. Okay, past 3 conversation, no, not more than that. Now let me create the chain. So this is my chain. You can see inside that I'm passing the LLM memory purpose is equal to 2 because I want to see the execution log. Now let me show you. So here I'll be giving one input. Let's say this is the input. Hi, my name is Bappi. Okay, now this is the response. Hello Bappi, nice to meet you. How I can assist you? Now let me give another question. So here I'm asking, my favorite color is blue. So you can see this is the question I have asked, and this is the history. Hi, my name is Bappi. Hello Bappi. You can see that this is the history. That means the previous history it has remembered, and this is the current response. Now let me ask another question. So my favorite animals are dogs. So my favorite animals are dogs, and you can see my favorite animals dogs. That means it will only remember 3. Okay, 3 conversation, not more than that. Let me ask another question. I would like to drive a Vespa scooter in the city. Now here I'll give another input. So my favorite city in San Francisco. Okay, now here I can ask something. Let's say, what is my favorite color? I think you remember I've given one question. My favorite color is blue. Okay, here. Now if I'm asking what is my favorite color, so now tell me, will it remember? No, it won't be remembering. You can see, I'm sorry, I don't have the enough information. Would you like to share your favorite color with me? Because it has only saved the top 3 information. Okay, the top 3 conversations. So here you can see it has saved this conversation. My name is Bappi. My favorite color is blue. No, I think last 3 conversation. I'm sorry guys. Last 3 conversation. What was the last 3 conversation? My favorite color. No, not this one. Here. My favorite city is San Francisco. I would like to drive a Vespa in a city. And my favorite animals are dog. Now here you can see, you can simply ask, let's say, the last question you have asked, my favorite city. So here you can copy this one. And here you can ask, what is my favorite city? See, it will be able to give me the response. What is my favorite city? See, your favorite city is San Francisco. Okay, so that's how you can control this window. Okay, with the help of this this one, buffer window memory. Very simple concept, but again very important. Okay, very important guys, try to remember. So if you're creating any projects, definitely this functionality you have to add at the end. And I've showed you both of them, like how we can remember the entire conversation, how we can specify some certain conversation. You can do anything, and this is called actually temporary memory guys. Okay, temporary memory, because if you close the application, it will clean all the information. Okay, but we have to build some permanent solution. Let's say if I'm closing my application also, let's say in some cases my application is crashing. It's not like that it will forget everything. No, it will remember. And how it will remember? For this you have to create a permanent solution. And again, with the help of this buffer memory, we can also create a permanent solution. We can save these are the information in a file. I'll tell you. Okay, going forward we'll be creating the project, that time I tell you. Now there is another one, we call it as a permanent memory. So we'll be using with the help of LCL most of the time. That time actually we'll be understanding, but let me give you some high level overview. Okay, which is called actually chat history. Okay, save the list of the chat messages and then fetch them all. So this is the idea of this one. Now let me show you example. So let me define my LLM. Then here is one example I can show you. So you can see I'm importing this chat message story. Then we are creating an object and we are adding some message. Let's say hi and WhatsApp. Okay. Now if I execute and if you see the story message, okay, see it is saving the information. Okay, so here you have asked hi and AI message WhatsApp. So here you can see user, add user hi, and add AI message WhatsApp. Okay, you have specified the format, but see, as of now, I told you we'll be showing you the high level demo, but whenever we'll be creating the application, so that time we'll be using like that. So let me show you in the beta mode. So here is one example, guys. So here is the example. So we have to create a function, okay, session function. So with the help of that, we'll be using this particular, let's say, statement. Okay, so this thing we'll be learning later on whenever we'll be creating some project. I think that will give you like more sense, okay, how we can use the this memory actually. Okay, but if you want to make it this memory as a permanent, the buffer memory you have learned, so we have an amazing actually idea we can follow. Okay, usually. Great. So yeah, so this is all about our memory. Okay, memory inside Langchain. So apart from that, I think you don't have anything. You can still see the documentation. So they've included so many things, but I don't feel like it is required. So memory, so chat message. So I have showed you this example, and beta memory. That means this buffer memory also I also told you. So memory in LLM chain. So we have already discussed the buffer memory. Okay, as well as the window buffer memory. Yeah.